All right, guys, let's wrap conversations, get back to the presentation. So this is usually the hardest part of the day. The slot after lunch is usually known as nappy time. While you guys are all tired, we're going to get to talk a little bit about insecure direct object reference, which can tend to be some of the boring topic anyways. So hopefully we can all stay awake. We can have fun here. If you guys have any questions, if you have any problems, again, feel free to raise your hand, ask those questions. Let's keep it light, keep it entertaining. Speaking of which, anybody has a good joke? No? I don't need it. It's just the UDP one was really the only one I came with. All right, so insecure direct object reference. What is this? This occurs when a developer exposes a reference to an internal implementation object, like a file, a directory, a database key, and without any sort of access control check or other protection mechanism, the attacker can manipulate these references to access the unauthorized data. The impact here is going to be moderate. These flaws can compromise all the data that could be referenced by the parameter. So unless the object references are unpredictable, meaning that those reference identifiers are random, they're long, it's not sequential or something like that, then it's really easy for an attacker to access all the available data of that type. And we always have to consider the business value of the exposed data, as well as the business impact of public exposure of the vulnerability. So here is an example. Thank you. In this case, we have a user. This is like perhaps a banking application. And the user has access to statements 1 through 12. And if they pass into this ASP application, statement ID equals 3, then they will get number 3 out of the database. Now again, this user has access to 1 through 12. What a malicious user or an attacker might do is they might say, okay, well I know I have access to statements 1 through 12. What about statement 17? What happens if I put 17, a statement that I don't see, that I don't have access to, into there? And so they enter that into the statement ID parameter, and lo and behold, they get back statement 17. Right? This is a very real issue, especially if you have things in your environment that are sequential, or that are easily guessable. And I'll tell you that we actually had this at an eye a long time ago. We found this with order IDs, where order IDs were basically a sequential value. So if you knew an order ID, you would basically be able to know all of the order IDs, right? Because you just look up forward, you can look back, relatively easy to write a script or something like that. We'll talk about that in a little bit. But in this case, what somebody did is they said, okay, well, let's take this order ID parameter and let's start with 0. Well, let's just start incrementing. And sure enough, after a while, it was 4, not found, and then they started getting results. And the end result was that they were getting every single order that had happened because they're now traversing them in order of all the order IDs, right? So what we ended up doing is we basically ended up changing that order ID value that they were querying, and instead we basically used a function to translate those order IDs. So you had to look up effectively a long random value that then translate to the order. So how do we test our applications for this? This can be really hard to automate. Automated scanners do not know what the user should have access to, right? It can't tell that this user has access to 1 through 12, and that user has access to 13 through 24, and so if that user accesses number 2, that's bad. Our scanning tools don't know that. So what we want to do is we want to inspect the parameters that are being passed to our applications. We want to look at pages whose only purpose is to display information about a single object. And so we want to look for things like documents, accounts, statements, things where I should only have access to that thing or the things that belong to me. And if I'm able to look at something else, then that's a problem. So in terms of automating exploitation, I mentioned in my environment that we have this issue. It's super easy. All you have to do is write a script like this that basically says, start at 0, keep looping for forever, get this page with this parameter equals to I, and then test the page. And if the result of that page is, move on to the next one. If it's good, let's capture that information because we have a good order ID, and then move on to the next one. And so the end result from the attacker standpoint is they basically get a list of all of the good values. If you want to try this out, I mentioned WebGov earlier, there's an access control clause, bypass a path-based access control scheme. That's directory traversal. Is a good example of this. So mitigations here, don't expose internal keys or identifiers. If you have like a table ID or a order ID or something like that, to expose those publicly basically means that you're giving the attacker a way to query that information. Instead, what we should do is we should use object references that are challenging to guess. We sometimes call these WID. Basically a long random value that represents that. And then on our server side, we should check the authorization for access to that object. So the user would basically pass in this GUID. The GUID would understand that this, or the system would understand that this GUID corresponds to this ID, this statement, this account, this whatever. And then it would check, does that user that's requesting it have access to that thing? And provide that the user does have access, it would say, okay, here you go. If it doesn't, we probably want to log that information and then not give it to them. So pretty simple. To recap, insecure direct object references occur when an application exposes internal references to objects via parameters that are passed to the application. And to guard against it, don't expose internal keys or identifiers. Use object references that are challenging to guess, and perform server-side authorization checks for the objects that are being accessed. In terms of references, OWASP top 10, the 2007 insecure direct object reference. I mentioned Asahi earlier, and then a couple of different CWBs, depending on what you're looking at. There's one for insecure direct object reference, and then there's also one which is path traversal, which is an example of an attack that you can conduct here. Questions about that? Yeah.
I've had to remediate exactly this problem because I've demonstrated that you can do it using WebGov. And it's difficult to remediate when it's systemic. But one of the things that I do is generally the dependent objects are carrying a foreign key that scopes them to a particular client or customer or something. You modify your where clause to join on both the key, the primary key, which is what is exposed, and the foreign key.
Yeah.
And they can't get stuff that's not theirs.
Yeah. So basically what she's saying is that in the database that there are multiple different references that you can join together and say you have to have both of these in order to be able to access them. Certainly could do that. I think the better option is to basically just go through, generate random identifiers, create a new column in the database for that random identifier, that GUID, and then change your reference lookup to look up that value. That way you're not worrying about how the other data was generated. You're not worrying about whether it's random or not. What if they have both pieces of information, right? You could apply like a temporary fix, which is what we did initially, which is say, okay, well now you have to have the order ID plus the zip code, right? But again, zip code can be guessed, it can be assumed, that kind of thing. So it may take a little bit longer, but the end result is the same. The best way to do this is to use those long random GUIDs so that somebody's not going to be able to force that value. Make sense? Other questions?
If you happen to be using Oracle, it's already there. Oracle has an internal row ID, which is a GUID.
Awesome. So Oracle has a GUID that's already built into it. That's basically a row admin.
But if you refresh the database, then it changes.
Oh.
And so,
Okay. So if we refresh the database, the GUID is going to change, and that could certainly be a problem. And I guess at that level, it probably depends on how our application handles that. If our GUID is something that gets presented to the user as a result of the UI interaction, right? If I go to the page that lists my accounts and those are the accounts I have access to, that's probably okay. If it's something where that got sent to them in an email that they're going to reference later or something like that, it's probably a big problem, right? So yeah, other questions or observations? All right. Dan, you want to talk about security misconfiguration?
Yes.
Yes, he does.
All right. All right. I think in a lot of cases, or when we look at application security, I think that there is like often a perception among developers or among some security people that this, like once they learn about application security, they start to think, well, this is only a developer problem, right? And so there's code changes that need to happen for all this stuff to be fixed. But what we've identified, what OWASP has identified, what we've seen as well is that it's not just a developer problem, it's also an operations problem. So maybe that makes it a DevOps problem. I don't know. What this looks at is saying that in addition to writing all the code and doing all the coding things right, there's also a lot of operational stuff that needs to be done correctly. And as organizations I think are starting to wake up to now is having an artificial separation or walls built between the development teams and the operations teams leads to bad outcomes from a software development standpoint. But also from a security standpoint, having an ignorance on either side of that skill set of what the other group is doing or could be doing, should be doing, also leads to issues. And so, in addition to writing code correctly, you also have to make sure that as these applications make their way from development through testing, through pre-prod and production, that when they make it into production, that they have the appropriate security configuration settings. And so when we're looking at the concerns about security misconfiguration, what we're looking at is making sure that we have that the application, that the frameworks the application uses, that the application servers that the application is deployed onto, the web servers that are serving content, the database servers, the platform as a whole, like all of those have configurations that are going to impact the ultimate security of the system as a whole. And from an attacker standpoint, if they can steal data from a SQL injection vulnerability in the code, that's one avenue for attack, and that's great. But if they can also steal that same data from the database because the database port is open to the internet and the SA user has a bad password, from an attacker standpoint, it doesn't matter how they're going to get in. And it's important to understand that the default configurations for a lot of these systems are often insecure. And that's something that's gotten a lot better over time. When I think back to like Windows NT, Windows Server 2000, all those internet worms and things like that associated with it, where by default installing a Microsoft server, you had like everything turned on. Internet printing was turned on. Why do you need internet printing turned on? Did anybody ever use internet printing? Only bad guys use internet printing, so it's stupid to have those things turned on. And Microsoft certainly has gotten a lot better over the years with their trustworthy computing initiative. That's been, that was a big push that they made for secure defaults. But this is something you've got to pay attention to. And the impact here is kind of all over the map depending on the severity of the misconfiguration. So it averages out to something where the impact, if you want to look at it, on average the impact is moderate. You can certainly have systems that are completely compromised without you knowing it. You could have data stolen or modified. Recovery costs could be expensive. And so this is something certainly that you need to pay attention to. And so when you're looking at your systems and asking, am I vulnerable to security misconfigurations, there's a couple things that you want to look at. And it's really looking through the application stack to make sure that at each level that you have addressed potential concerns with configuration. And that you understand how, as as software moves from a pipeline standpoint, from a developer's workstation to a QA environment and finally out to production environments, that you know how these steps are going to happen. And the good news is with a lot of moves now toward infrastructure as code, that makes it a lot easier to standardize this, right? When you're installing a new server, you no longer have to you don't just swap floppy disks or CD-ROMs or even DVDs and remember to click through the install in the same way every time. There's a lot of tools available now that make this infrastructure as code a lot simpler to say, this is exactly how I want these systems configured, and I want it to be configured the same every time, right? But an important question to ask is, is any of the software that we have out of date? So that means looking from an operating system standpoint, from a web and application server standpoint, from a database system standpoint, the applications, the associated code libraries. And this hits a number of different questions or concerns where you may be scanning with an SS or an Expose at the OS level. Those will also, in a lot of cases, check versions of web and application servers. There's specific database scanners that will look at configurations. Code libraries, you can use the software composition analysis. But that's a question you need to answer is, of all the pieces that are coming together, are all of those up to date? Another really important question is, are there any unnecessary features that are enabled or installed? Right? If you run nnav against your server, what ports is it responding on? And what's ports should it be responding on? Is it just 80 and 443? That's a pretty common scenario. Or do you have a bunch of other stuff open as well? What are the services that are turned on? What are the accounts and what privileges do those accounts have? Another question is, are defaults enabled? Are the passwords set to defaults? There's if you can search out on the internet for databases or libraries of for this software, here is the admin account and here's the default admin password. And so we're looking at your environments, are those default accounts still on? Are they enabled? And do they have the original passwords? Because that's the type of stuff that's really easy for folks to track down. We've talked about this in other contexts, but from a configuration standpoint, have you configured your application server, have you configured your applications so that they are providing error messages that aren't helpful to attackers? And similarly, if you look at the frameworks that you're using, Spring, Struts, ASP.NET, are the configuration of those frameworks such that they're enforcing good security principles? And that's something where what you see in developer environments is not a lot of attention gets paid to this, right? I just need Tomcat running on my workstation. I'm going to deploy some code to it. What do I care if the Tomcat manager is exposed, right? In my environment, that doesn't matter. But if that same level of rigor or lack of level of rigor is applied as that software makes its way out to being public-facing, then you run into issues. All right. Same thing with permissions on developer workstations. All right. If you're going to be developing an application and you may be making changes to the database, you may have a more privileged database user that you're using in your development environment that's not appropriate for production environments. Similarly, if you're developing on your workstation, you probably want to see the verbose error messages because you want to know what went wrong before you go digging into logs so that you can actually fix those problems. And so it's important to pay attention to the reality that what is acceptable or what is even desirable in a development environment may be different than what you want to see, or almost certainly is different than what you want to see in a production environment. And without a concerted effort for this, and a way to make it repeatable, again, which infrastructure as code is fantastic, these systems are at a very high risk. And again, it's going to depend on, in certain environments that we've worked with, there are very strong controls on how applications get promoted out through production. And again, highly highly regulated environments, you see a lot of effort that's around this. In less regulated environments, you see a much more laissez-faire attitude toward this, and you don't necessarily have those separation of duties between the people that are writing the code and the people that are pushing production code out to servers. And so this is something to understand. It may be something that's very mature in your environment, or maybe something that's less mature in your environment, but it's certainly something to pay attention to. So one example or a scenario to look out for is your application server admin console is automatically installed, not remove default accounts to change. An attacker can discover this just looking for well-known URLs, find the standard administrative server pages are there, log in with default passwords, and then then they've got control, right? They can say, this application used to be running, let's take this application down, right? They can say, let's potentially install additional applications or other applications on the server. And so that's the type of thing that happens in environments where you don't have strong controls, saying the Tomcat server that I want to use for development is not configured the same way as the Tomcat servers we want to use in production. Another scenario, directory listings being enabled on the server, or not being disabled on the server. Attackers find out that they can just go to a directory, /admin, and see a list of all the files that are in that admin directory, some of which may be executable, some of which may be others. Right? So we've seen a lot of problems with this in environments, running like Cold Fusion and things like this. Anyone here still maintaining Cold Fusion applications? Hopefully not. Hopefully not. We see a lot of challenges with ASP Classic with Cold Fusion. Thankfully, a lot of those are going away, and we're seeing more like dedicated web frameworks that have built-in controls against this. But it's also still something we see from older applications, situations where there are challenges with this. There was one organization that we worked with where they, to take things into production, they just copied the developer's directory and unzipped it. They zipped it up, unzipped it on the server. Unfortunately, the developer on their workstation had all the Cold Fusion files. They didn't have strong version control in place, and they had a lot of file.cfm.back. Right? Well, what does the web server do when it gets a request for a .cfm file? Well, it knows it's Cold Fusion, compiles that, runs it as an executable. What was the behavior of the server when you requested a .bak file? Grab the file and send it back. Right, so when you go to a directory list, you can see here are all the files in the directory, including the .back files. You can pull back an earlier version of all the Cold Fusion files, and essentially an attacker was able to get all of the source code for this application, by directory listing and then by pulling back selected files. And so the challenge there is, again, if you don't have mature practices around how code gets pushed into production, you can run into scenarios like these. Yes.
It's been a while since I've written Java. Is it possible to decompile Java classes? So you take them back to the first one?
Oh yeah, Java's super easy. Java and .NET are pretty easy for that. Certainly easier than like C or C++. Java's pretty easy to decompile. I mean, depending on if debug information is in there, that depends on how variable names and stuff make it back. But Java is pretty easy to decompile from classes. .NET similarly, C and C++, less so. But Java's pretty simple. Okay, so when you take the question is what is decompiling? So when you take a language like Java or .NET, you take the Java source code, which is human readable, that gets fed to a computer program that takes it and converts it into another form. So like a class file or Java bytecode, and that's not human readable, but designed to be fed into the Java virtual machine and run. And there's a process called decompiling, where you take something that has been compiled and return it to a more human readable form. And that's something that for C and C++ that get compiled down to machine binaries, that it's possible to decompile it, but it's like you don't get to reverse as much information back out of that typically. But for languages like Java and .NET, they do tend to include a lot of kind of surrounding information that is used by either the Java virtual machine or the .NET runtime in order to run that. So just a characteristic of certain bytecode compiled languages it makes it is they're relatively easy to return to something that's human readable. Excellent. So we talked a little bit about this, but if your application server configuration is such that it allows the stack traces to be returned to users in cases where there are errors on the server side, this provides potentially a lot of extra information to attackers. Because in the stack trace, we're going to be able to see, well, number one, what language. In a lot of cases, you'll be able to see what version of the application server, what version of the framework is running. By looking at the stack trace, you can see, is this running Spring? Is it running Struts? You can see what framework, what application framework might be in there. In a lot of cases, there might be error message or snippets of error message, potentially even snippets of source code. And so failing to have a good configuration or control over configurations for these, for your application servers can potentially provide a lot of information to attackers. And again, that's potentially the difference between, well, I passed something in and I don't understand, I didn't get any information out to, I passed in a weird control character, I believe there's a SQL injection problem, I know that we're using Oracle as the database server, and by the way, we're using an old version of Struts, right? And so, from a, security through obscurity is not a strong, it's not strong as your only security approach. Like, you should never assume, like, hey, the bad guys are never going to be able to figure out what we're doing here. But certainly the flip side of that is, like, obscurity is an excellent defensive depth strategy to deny attackers as much information as possible. Right? You don't want to make their jobs any easier than they may already be. And misconfiguration of servers leads to information leakage, and that causes problems in a lot of scenarios. Scenario number 4, example, your application comes with, or your server comes with a number of sample applications. You don't remove those from production servers. These sample applications, again, because they're written as toy applications or just to demonstrate certain points, they may have vulnerabilities in those. An attacker can find those applications because they're going to be in well-known locations and potentially exploit those vulnerabilities. So, what you want deployed to your server is only the code that needs to be there to run the applications that you've written, right? You don't want to include, bundling management consoles, bundling sample applications. There's no reason to have that stuff out there. There's no benefit to it, and there's only downside because, again, in a lot of cases, the URLs where those applications would be installed are pretty well known. There's databases of that information available, and that's code that's running. Additional code that's running is code that could have problems with it. So, that's not the kind of stuff that you want running in production environments. And so, how do you prevent security misconfiguration? So really what you need to establish is the following, and this is a repeatable hardening process that makes it fast and easy to deploy in another environment that is properly locked down. So we've talked about the development, QA, production environments. Like, you want to the greatest degree possible to have those configured identically, especially when you get past the development environments where you may need certain debugging or other capabilities. Automation is critical here, right? I mean, humans are fallible, they're lazy, they all kinds of horrible things that I am a human. I have all the bad habits, I assure you, right? And there's a great book called the Checklist Manifesto that looks at the use of checklists in medical environments where you're dealing with doctors and things like that. Like, doctors are smart people, right? Anybody here a medical doctor? Would be a weird visitor for the class. It'd be great. It'd be great. But you figure doctors are smart people. Made it to medical school, not easy. Organic chemistry, not easy. Doctors, smart people, which is great. But if you look in hospital environments, you see all of these mistakes that cause all of these costs and this human suffering. The Checklist Manifesto looks at, like, okay, hey, what if we start implementing a simple set of checklists? Ask the doctor, did you wash your hands before the surgery, right? Did you remember, like, did we check to make sure all of the scissors and clamps that we don't want left in the person came out of the person, right? This book it's incredible to see just how simple things like that, simple checklists like that, help to prevent errors. The same thing with aviation. I've got a buddy or a couple buddies who run a company called ForeFlight, and a big thing that they implemented was the checklist, right? Before you take off, any private pilots in here? No. More likely than doctors, maybe. Not today. No, but there's a checklist. Hey, have you checked the left flap? Have you checked the right flap? Have you pulled the little thing on scissor remove before flight? Those checklists save lives because if you assume that that stuff is just going to happen because you're a smart person, that's not a safe assumption. The great thing about computers, you can automate stuff like this. You don't have to rely on checklists. A checklist is better than nothing, but this is the type of thing that you can use in systems like Puppet or Chef to make sure that every time something gets deployed, it goes through the same set of steps, goes through the same process, the same set of checks before something gets pushed into production. And so that's something you need. You want to have as repeatable as possible, preferably stored as code, so that it can be versioned, it can be rolled forward, and you can control those practices in a very explicit way. Another, step 2. How do you keep abreast of deploying all the software updates and patches in a timely manner into your various deployment environments? This also includes code libraries as well, which are frequently overlooked. And so again, the challenge here is you've got at different levels you can have problems that you run into. And the people that care about the server configuration in a lot of cases aren't the people that care about which version of the components you're including in your Maven build. Right? In one case, it's maybe a server operations team. In another case, it's a developer. In the magic world of DevOps, clearly that's all been solved, right? But what we see is overlapping or different tool sets that aren't necessarily matched up. But your concern is in our production environments, we want to make sure, have we applied the appropriate software updates for the operating system, for the web server, for the database server, for the application server? And have we upgraded any components that are included in the build with the latest versions that don't have any known security bugs in them? Also, you want to look at having a strong application architecture that gives you the separation between these different components. Again, from a defense and depth strategy, so if you have problems in one area, you aren't necessarily going to have problems with the other. And also, you want to have a program of checking to make sure, right? Number one, is the environment that I have created, did the environment that I create, has it drifted from where I think it should be? And number two, has the world drifted away from me such that, new vulnerabilities are always being discovered in software and operating systems and libraries. Just because you have a configuration one day that is secure, the following day when new vulnerabilities are identified and disclosed, when new problems with libraries are identified and disclosed, the world can change, and given new information, you can now know, well, the configuration I thought to be secure yesterday, now I have provable knowledge that that configuration is not secure today. And so this is something that from an operationalization standpoint, you have to be able to track. As potentially environments you've created drift because of people's access to system or other no-nos like that, but also because the world moves forward. Like from an attacker standpoint, attackers get better every day because they're always they have more time to find bugs, to find vulnerabilities, and they have more time to find problems with configurations. So every day that goes by that your system hasn't changed, it is monotonically becoming more vulnerable to attack. So to recap, when we look at security misconfiguration, this is something that developers have a role to weigh in on. It's an area where operations teams have a role to weigh in on. Again, how that gets configured in your environment is going to vary. Organizations have different org charts, different ways they divide responsibilities. But it's important to understand that secure applications don't just come down to secure infrastructure, and they don't just come down to secure code. Secure applications are secure code that is written and deployed into an environment that is appropriately locked down. And so in your environments, that's an important thing to pay attention to. And we see, again, like the traditional view of security was very network and infrastructure based. Do I have a firewall? How do I run Nessus? And not paying attention to the applications. Right? That's bad because there's vulnerabilities in applications. In a lot of application security programs, the focus is very laser-like on the code, and that fails to pay attention to the infrastructure and the surrounding configuration that's important. If you actually want to have secure deployed application, you need to have secure code that is deployed into secured infrastructure. And it's important to look at this from a stack perspective, all the way from your operating system platform, your web servers, your application servers, the frameworks that you use in your applications, all the way up through your custom code. And as a slight plug, tomorrow, for anybody who's attending the actual LastCon conference, I'm giving a talk at 10 a.m. Looking at what I call the 4 C's of secure cloud native applications. It's looking at applications intended to be deployed into the cloud. And what we're going to talk about is looking at that stack adjusted for the cloud. So looking at your custom code, the components, the compute that's running, the cloud configuration that surrounds it. So if you're going to be there, if you're going to be at the conference tomorrow, please feel free to stop by at 10 if that's something you're interested in. And we'll be touching on some of the things that we've talked about in this little section here. So to prevent, again, you want a repeatable hardening process, ideally automated. You want your configurations to be as similar as possible, with dev being the potential exception, just because if you need access to different development tools, you need different capabilities in dev. But your QA and prod, you want those to behave as they're going to behave in production. You want your build process automated, so that goes through the same steps every time, and so that you're repeating those hardening steps every time. You need a process in place in your organization for tracking software updates, and that spans both the software patches that you would apply at the operating system, web server, database server, application server level, as well as tracking the versions of components that you have rolled up into and along with your custom code. You want a strong application architecture that can enforce the separation between pieces, and you need an ongoing scanning and audit process to make sure that your environment hasn't drifted from the baseline that you set, and that the state of the world hasn't drifted such that the baseline you set no longer provides you with the level of security that you expected. Here's a couple of OWASP links that look at different aspects of this, as well as some external comments, both from the MITRE folks and the CIS folks provide really good kind of baseline benchmarks for configuring common operating systems and web and database servers. So those are some valuable resources. And now, if Josh is ready, we'll turn it over for sensitive data exposure. First, I'll open up. Apologies. I'll open up. Were there any questions about anything we talked about? Yes.
Should I, as an AppSec guy, be concerned if they're using an older jQuery library, if they're not actually using the functions that are picked up in Synac as being the cross-site scripting vulnerability?
Yeah, so very quick. The question is, so in an environment, if the application is using an older jQuery library, even though they're, the certain vulnerable functions aren't being used, that's a tough call. And that's like an argument that I've had with various people, usually from vendors that do that type of testing. Where they say, well, you've got vulnerable libraries. And like the flip side of that is, well, we're not using the functions in the vulnerable libraries. So a couple thoughts on that. Like one is, like in certain cases, like with struts, just having that struts jar file like in your environment, like made you susceptible to vulnerabilities. And so that is one argument. That's probably the most compelling argument I've heard for, like, yes, this is something where you need to make sure that you're upgrading things, because in certain cases, there have been vulnerabilities where just having the vulnerability library included in your application made you susceptible. When you look at libraries that have vulnerabilities, but you may or may not be using vulnerable functions, that's a tougher call, right? Because to take the hardline view and say, we've got to upgrade this all the time, that works great in like security land, where security is the only thing that matters. That plays less successfully in environments where we appreciate that we have security land, but we also get the release on time land, right? And so that's a situation where you've got to make a tougher call. Some of the vendors are doing a much better job these days by including some data and control flow analysis to say, you've got a vulnerable library, but it doesn't look like you're using the vulnerable code, right? And that's something that has been, that's helpful, because it helps you to prioritize. It provides you that context that you can use to make a good decision about what do I remediate and when. And the danger there is obviously developers, code changes over time, and so that's a tough call, especially when you look at like embedded JavaScript frameworks or libraries or things like that, where like if you wanted to go and replace those, it's not necessarily just like swap it out with the new version because that's in certain cases there's not a straightforward upgrade path or something like that. So in cases like those, you've got to make tougher decisions, a risk decision to say, here's the vulnerable component, here's how we're using it, here's what we believe our risk is, and we're going to make a decision to say we're going to accept this risk and use the older component for some period of time, or we don't want to accept this risk, we're going to patch the component, upgrade the component, go through the changes to rip it out and replace it with something else. And so I think the important thing is to be able to, or is to make those decisions explicitly, because if you can say, hey, we know we've got a vulnerable library, and we're going to keep it around for the next couple months because we've got a release to finish, right? And that is everything in life or everything in security is making those risk management decisions. And the ability, if you have the information, then you can make those decisions, and business owners can sign off and say, you've characterized the risk, I value the release more, let's go. Let's go ahead and leave it. Again, you've characterized the risk, and yes, we're going to take the hit for that. There's to have doctrine for that is not necessarily valuable, but to be in a situation where you can explicitly make that risk, I think is the important thing. Nope. Right. Yeah. Sorry. Yeah.
So moral and code libraries, do you have any recommendations for mitigating against the NPM code models when the author has been swapped out for a malicious author that's doing Bitcoin mining and various other things?
Yeah, so the question is, for NPM modules and open source, being able to, in situations where the original maintainer may have been replaced with somebody that's now including malicious stuff. The most important thing there is to is to have a process or some tooling in place that notifies you when that is, when that has happened, so that you can roll back to an earlier version or something like that. That's an unfortunate thing about the use of open source is that I'd much rather have access to open source because I can get way more done way faster. From just an economic standpoint, it's not realistic in most cases to not use open source unless you're doing really specialized stuff. The flip side of that is, you have a risk of, a library that was, where a maintainer is switched to somebody that's malicious, a library where it was started by somebody malicious and they just waited for a lot of people to use it. Most organizations that I know of aren't doing a lot of the primary research to detect those things, but rely on data feeds from, some sort of software composition analysis scanner to identify those situations. Again, the important thing there is to have a scanning process in place that will let you know when those things may have changed, and then you can make a decision of how are we going to react to this now that we know that the world has changed. But it's good to know that that's happening. And again, I think there's been some interesting stuff going on at OWASP, looking at the controls for those, because if you think, those repositories like the Maven, the NPM, those are becoming world infrastructure items, right? Just given the amount of code that flows from them and the amount of code that impacts, those are internet infrastructure, and hence very important. Again, the important thing is to have some tooling and a process in place so that you get that intelligence and you can react in a sensible amount of time. Question over here? Yeah.
We're talking about a cultural problem, right? The 100 devs, there's one infosec.
Right.
I can detect the transient dependency issues, right? But how do I get people to actually remediate them short of going and pairing with them and correcting them? There's one of me.
Right. Yeah, and so the question is about a cultural problem of a ratio. If you're lucky, you have 100 developers to one security person. How do you get them to make those changes? And that's a big question. If I had to answer that problem, I'd be super rich right now, and the world would be a much better place. But it's one where I've found there's things you can do from the grassroots from a standpoint of educating developers so that they understand. In my experience, I think a lot of security curmudgeons like to think that developers don't care about security, but that hasn't necessarily been my experience. It's developers care about security, but they also have to care about features that need to be delivered on a timeline, and non-security related bugs, and a variety of different things. And so, I think that from the ground up, I think there are a lot of opportunities for education to get developers understanding about security, understanding about the risks that they face, and getting them to incorporate that into the things that they're doing. The flip side of that is, like, to really drive a lot of change, the organization has to value security, right? Or has to factor application and software security into their decision making when they allocate resources. And so you need, to some degree, either some sort of mandate, whether that comes from a regulatory standpoint to say, hey, PCI says that we have to do this, or our PCI auditor says that these things have to get fixed. That's kind of a hard power approach. Or for other organizations to recognize, again, from a brand standpoint, hey, our customers may not think of us this way, but we are a software vendor, and like if we're mining bitcoins on our customers' computers, like that's going to come and that's going to damage our brand, right? Like our inability to create software that is acceptably secure is going to damage our brand, it's going to damage our customers and things of that nature. And so, from the bottom up, you can, there's like awareness things and kind of influence and stuff that you can do, to really move a lot of, to really change behaviors from a culture standpoint. Like that has to come from the lines of business, from the product owners, or from the executive level to say, like, this needs to be an important thing that we do. And so I'll just a quick anecdote. We were doing training classes when, for PCI, we did a bunch of training at a bunch of organizations, but two of them stand out very explicitly. And in one organization, they brought us in to do training for their developers. And it was a mandate for PCI compliance. You have to train your developers on secure coding, like the OWASP top 10, right? It was a requirement for PCI compliance, which is for if you're taking credit cards. One organization, I showed up and they had like a easel that said like PCI training, right? And the developers have been given no context whatsoever about what they were there to learn, right? And so it was like, okay, hey everybody, we're here for OWASP top 10 secure coding training, and I'd flown in that morning on a super early flight, and I said, like, hey, for everybody, like, what's your background? What do you hope to get out of this class? And one fellow folded his arms, looked at me, and he said, I'm only here because my boss told me I had to be. I said, me too, man, me too. I didn't wake up at 4 in the morning because I thought it was fun to fly out here. But that was a real uphill struggle because the developers were saying, hey, we have to check a compliance box, so we're gonna send you to the least amount of training possible, providing no context of how this fits into what you're doing. We're providing no explanation of how you're going to change your behavior based on this training. Just go there and make sure that you get the certificate of completion, because we got a dude that's coming around in a little while. We got to show him all the certificates, right? Now, I would argue that we did our best. I don't know how successful our outcome was from that training. Another organization we went into had a video from their CIO and from their head of development, right? So they watched like two-minute videos where the CIO said, hey, like we have such a great relationship with our customers, we value this, but that relationship is based on trust. And so one of the things that keeps me up at night is protecting our customers' information, because if we have breaches of this information as a breach of trust, that damages our brand, it's going to damage our relationship with our customers, right? And so, this is why this training is important, because building secure applications helps us maintain the trust that is critical for the relationship that we have with our customers. Right, and then it was echoed similarly with the head of development talking about like, hey, here's why we're concerned about this, here's where it fits in, right? Like, in the organization that had that top-down message that says, here's why this is important, here's how we value it, here's how this fits into our overall strategy, they're going to have, they arguably had much greater success and got more value out of the training versus an environment where it was like, hey, everybody, show up, get your cert at the end, and make sure that you sign your name at the bottom of the form, because somebody's going to check that to make sure you're there. And so that's a challenge that we've seen is like to really move mountains. That has to come from the top, and so it's InfoSec's job to provide that context to the folks at the top to get them to understand this is how security fits into our overall strategy and risk management.
You mentioned scans and periodic audits. Are those other tools for doing those scans and periodic audits?
Yes, the question is about the tooling for doing scans and periodic audits. Yeah, and so if you're looking at the configuration and patch levels for servers and web servers, application servers, then you have things like Nessus and Expos, Qualys. You provide that type of scanning. If you're looking at the configuration or at the security level of libraries that you have included in your code, then you've got software composition analysis tools like OWASP dependency check, which is free. As well as other vendors in the space, Sneak, Sonatype, Black Duck, White Source. And so there are kind of product classes that talk about or that speak to those those different scanning at those different levels. And there's both commercial and open source tools at different levels for those.
Are they included in the references?
I don't know that we have any commercial tool references in here. We do have links to different OWASP resources that are out there available. So, yes.
Going back to her question, if you're an agile environment, you have like quarterly or semi-annually security scrums.
Right.
Schedule those, and then it would be on the security officer to say, here's the thing that we're going to focus on. Here are the examples of where we see things, this week, we're going to fix it.
Right, that's a great point. So he brings up if you're an agile shop, or in a waterfall shop, you can do like a mini waterfall, but I think that probably works more, fits more into an agile type of approach, where you can say we're going to have a security scrum, or we're going to have a sprint that's dedicated to addressing this technical security debt, and then interacting with the security officers where they can help to prioritize, like, hey, of the things that we have out there right now, this is the stuff that we're most scared about. How much of this technical debt can we chew through given this budget of time that we have in the security scrum? So that's a really good point, and that's something that we've seen used effectively in different organizations, something we've used in projects, in dev projects that we've run, just to say, hey, we're gonna have at least some ongoing budget for dealing with this technical debt of whatever sort. Because an interesting perspective that I've heard is, just as debt, you compound your interest, technical debt compounds over time as well. And so in a lot of cases, it's easier if you have an ongoing process to address that stuff rather than getting to a point where, you're in a situation where it's just like the things you need to do are untenable or force you to make really, really nasty decisions. So, yeah. Yeah, so is security, I do view security as technical debt. There are problems that you have that are more acute, where leaving them around is less acceptable. But when you start to get into vulnerable libraries where you don't know if they're exploitable, vulnerabilities or misconfigurations that are problematic but don't necessarily have a super high impact, like that stuff in a lot of cases just gets kind of pushed back on technical debt. But that's the stuff that tends to accrue over time if you don't have a process in place to sort it out on an ongoing basis. Well, all right. Well, we'll bring Josh up here to talk about sensitive data exposure.
So in case you didn't get my UDP joke, I got another one for you. An IPv6 packet walks into the bar, but nobody talks to him. Thanks. Security dad jokes. That's awesome. All right, so let's talk about sensitive data exposure. What is it? Many web applications don't properly protect sensitive data. And sensitive data can be a really wide range of things. It could be things like credit cards, tax ID numbers, authentication credentials, HIPAA information could be considered sensitive, proprietary things could be considered sensitive. It's kind of up the subject, right? It's subjective. What?
If they don't protect credit card information,
Oh yeah.
you get cut off.
So the interesting thing with PCI, right, which is what you're talking about, is yes, they could technically cut you off if you're not processing credit card transactions appropriately. The problem is so many organizations process credit cards that the reality is that they only go after the ones that are processing the most credit card transactions. So So it's not even by dollar value, it's by number of transactions. And so, like NI as an example, we're PCI level 4 merchant, which is basically somewhere between, I want to say, 100,000 and 1 million credit card transactions a year, which that's a lot of transactions, right? And that's a huge gap. Once you start being under that, like if you're level 3, it's even less. I think it's like 10,000, 100,000, something like that. Once you get below that level, and you're like a level 2, level 1, they don't care about you. And it is solely up to your merchant bank to determine whether or not they actually care about you. So, you know, in certain cases, maybe your merchant bank does care and they go after everybody. In at least my experience, they are only looking at ones that are doing a large volume of transactions because the risk level goes up with the number of transactions you do. So attackers could steal or modify weakly protected data. It could do things like credit card fraud, identity theft, or other crimes. And because of this, sensitive data deserves extra protection, such as encryption at rest or in transit, as well as special precautions when exchanged with the browser. The impact here could be severe, right? Failure of this frequently compromises all of the data that should have been protected. So if we're not encrypting data in transit, if we're not encrypting our data at rest, and something happens where somebody has access to that data, it's gone. It's no longer protected. Typically, this information includes sensitive data. Right? This is the important stuff, and frequently things that are regulated. Things like credit card data, for example, they don't care about you until you have a breach, right? And if there's a breach of that credit card data, now you're like number 1 on that list, and they're going to be going after you hardcore. So the sensitive information needs to be protected. And always consider the business value of the lost data and the impact to your reputation. Speaking of regulatory and legal issues, I mentioned earlier some of these things. HIPAA is around the health information. California SB 1386 has to do with personal information for California citizens. PCI is credit card information. But if there's a breach of this information, this results in huge issues. It could be fines. It could be failure to be able to process. With something like Sarbanes-Oxley, it might mean that you're actually delisted from the stock exchange. For California SB 1386, there could be financial penalties. For GDPR, there's huge financial penalties. Some companies have been fined millions of dollars as a result of GDPR data breaches. It's a big deal, right? And so we want to make sure that when we're looking at our environments and we're looking at the data that we're processing, that data, if it is considered to be sensitive or if it's governed by regulation, that we're protecting it appropriately. So to figure out if I'm vulnerable, the first thing we have to do is determine what data is sensitive enough to require extra protection. And what that means is that there's probably some kinds of data in our environment that is not, right? There's probably things there, I mentioned earlier, like a white paper. That's probably not something that we want to encrypt. That's probably not something that we need to put layers and layers of defense and depth in front of. But passwords, credit card numbers, health records, personal identifiable information, those are all things that we probably would want to protect.
You're not allowed to store credit card numbers.
Yes, if you are following the guidance of Pci Dss, you are allowed to store credit card numbers in encrypted formats. What you are not allowed to store is the PIN or the CVV code that's associated with those credit card numbers. But you can store that. Some organizations do what's called tokenization, and you basically take that credit card number and you turn it into a token, which is, there's a one-to-one relationship basically between the token and the credit card number, but then you store the token, and if there's a breach, the token means nothing basically. But you are absolutely, according to Pci Dss, you are allowed to store credit card numbers so that you can recharge them and things like that. But your risk level goes up if you are keeping those credit card numbers around, and the guidance from Pci is that you purge credit card numbers if you no longer need them. So what that typically means is if you're not doing like a recurring charging model and you charge somebody, you keep that credit card number around long enough that you could refund them or something like that, and then at that point you delete the card from your system 90 days, 180 days, whatever the case may be. But the more card numbers that you store, the bigger your liability if there is a data breach. Okay, so to figure out if we're vulnerable, the first thing is any of this data stored in clear text long term, including in backups of the data, because backups are really important, right? If we have our data in a database and it's clear text in the database, and we back up that data to a backup tape, and then that backup tape falls off the back of the truck, which has happened in a number of universities and other environments, right? Now somebody has access to the unencrypted data. It didn't matter that that was encrypted in transit. It didn't matter that we had the database encrypted at rest. Because that backup was unencrypted, they now have access to that data. So we need to be cognizant of that. The second one is any of this data transmitted in clear text? And that means either internally or externally. Internet traffic is especially dangerous because you are traversing over things that you don't own, right? If it's on my intranet, I can at least say that I own the servers and probably own the computers that are processing these transactions, the network is mine, and I've done some level of diligence to protect that. The internet is wide open, right? And we cannot say that. We don't own any of that equipment. We want to make sure that if we're transmitting this data, that it is being encrypted, not transmitted in clear text. Third, are any old or weak cryptographic algorithms used? We've talked about PCI a couple times now. One of the things that PCI says is that you cannot use old, outdated cryptographic algorithms, and they actually specify what is or is not appropriate. I believe the latest guidance is TLS 1.2 is the minimum level, which means you have to get rid of TLS 1.0, 1.1, SSL v2, v3. You have to get rid of all those protocols from any server that's processing Pci Dss data. And then the internet is moving towards TLS 1.3. Our browsers support it, not all servers support it today. So that's kind of the direction there. Are weak crypto keys generated, or is proper key management or rotation missing? This is interesting because with respect to PCI, you're right, you can't store the credit card numbers in raw format. What you're supposed to do is store the credit card numbers in an encrypted format. And in order to store them in an encrypted format, you have to create a cryptographic key. And then that key is what's used to encrypt that data. PCI also says that that key is supposed to be rotated on a regular basis, which means that you have to have a process for basically taking that key, taking all the data, and then re-encrypting it with a new key. And typically what happens there is you have a master key that you use to encrypt all the data, and then you basically have another key that you're rotating on top of that, so you're re-encrypting the data, and then it's that key that you're rotating. So you decrypt and then re-encrypt with a new key. But we need to make sure that when we generate those keys, that we're using a secure format. And what that means is random isn't always random. So if you look at things like the random number generator on a Unix system, that actually by default is based on values like time and other seed values that could potentially be guessed. So the best way to do it is to actually use a true random number generator. We had a good talk at the OWASP Austin chapter last year, I want to say, where the guy actually talked about randomness, and he talked about a room full of lava lamps and then using the lava lamps to generate real random numbers. It was kind of cool, but something to be cognizant of. And then we want to make sure that those keys are being rotated on a regular basis, because kind of like the brute forcing discussion we had earlier, we need to make sure that somebody isn't going to be able to guess that key. Lastly here, are any browser security directives or headers missing when sensitive data is provided by or sent to the browser? So what this means is things like the secure flag, right? When I send data, if I don't provide that secure flag, my data is potentially going to be sent in clear text. And it entirely depends on how that browser handles that data, the other URLs that I'm going to, where that data is included in the page, is the page hosting it, secure, things like that. So we want to make sure that those headers are properly being set in order to avoid that scenario. So let's look at some examples. Oh, yes?
So on the previous slide at point 4, for key management, so how do you compare hardware-based key management versus software? Using a HSM versus like some some kind of JC memory, stuff like that.
Yeah, so HSMs are definitely the better route. They're purpose-built appliances with true random, at least in theory, built into them, and should definitely be used over the software-based ones. What typically ends up happening though is when we create a key, we don't have an HSM. HSMs cost money, and they're big bulky appliances and things like that. So what we typically end up doing is we use something that's not true random, it's pseudo-random. We use a pseudo-random number generator, which is built into the OS, and it uses values that are kind of random, but kind of not. Things like mouse movements, keyboard strokes, time-based seeds, things like that. I mentioned before, Sammy Kamkar did a really good talk called How I Met Your Girlfriend, where he breaks down PHP random, and he talks about how that number is actually created, and he was basically able to get back to, here's the number that was generated within a very small number of digits, basically using a certain methodology. So I would definitely recommend the HSM, especially for very critical context kind of things. But the pseudo-random stuff, the keys generated with that, depending on the data, may be sufficient, right? All right, other questions? Yeah.
I have a question regarding deprecated CLS ciphers.
Yeah.
The main of my existence are partially available tools or open source tools that will deal with that systemically and stuff. I mean, it's a problem because if you have APIs, you can't just change the cipher and strand your client.
Yeah.
If it's just a website, well, hey, I can know it here. So are there any tools that I'm aware of that do that?
The best tool that I found with respect to SSL configurations is SSL Labs. You can go to SSL Labs, you can plug in a website, and it will go through and it'll test all the different ciphers, and it'll tell you, here's what you're missing, and it'll give you a grade from an A down to an F for your SSL configuration for that site. And it will tell you, here's the reason why you got this particular grade. And you have to do this in order to get a better grade. It doesn't necessarily answer the question about like APIs and things like that, but you can use that on any publicly accessible URL, even an API, to look at the SSL configuration for that environment. Yeah, the other question?
Publicly accessible.
Publicly accessible, yes, SSL Labs. Yeah, internally you can use things like OpenSSL, you can use that to do testing of a system, but it becomes a lot more difficult. SSL Labs has done a really good job in terms of making that visible and easy to test. So I take all of my URLs, all the websites that I work on, I feed it into SSL Labs and I look at that configuration. Though I will say, if you use Let's Encrypt SSL certificates and you do it through certbot at least, you can basically tell it, go ahead and configure my SSL for me. And when you do that, it actually creates a secure SSL configuration. It sets the ciphers, it actually creates a file for Let's Encrypt TLS configurations, and it configures your SSL to use that. So in terms of like the easy button, again, publicly accessible, right? But in terms of the easy button, you basically do certbot -- Apache. You have to install some stuff, some Python scripts in certbot, but certbot -- Apache, and it'll list all of the non-HTTPS configurations that you have there. You basically push the number for the one that you want to make HTTPS, and it does all the configuration. It creates the virtual host entry, it grabs the SSL certificate, installs the SSL certificate, sets the TLS configurations, and restarts the server for you. So Let's Encrypt, SSL Labs are great tools for that. Other questions? All right. Is that great? Yeah. You want to do a rap, song and dance?
Yeah, song and dance and raffle off some things. I wanted to just interrupt here for just a moment and thank Josh and Dan for coming out and doing all this hard work today. We'd like to, as a token of our appreciation, give them this commemorative coin from LastCon.
We have to share it.
thank you for your applause and continue to get educated.
Thanks, man. You know, the interesting thing is you do enough things, like I've done the badge challenge now for 5, 6, 7, whatever number of years for last con, get a challenge coin for each year I do that, and this thing. This year I finally bought myself a case to display all my challenge coins. You don't have to clap, it's a problem, it really is. All right, so let's go through some example scenarios. The first one is we have an application that encrypts credit card numbers in a database using automatic database encryption. So a lot of databases do encryption at rest automatically, but this means that it also decrypts the data automatically when it's retrieved. It is purely data encryption at rest. So if you have a SQL injection flaw that allows you to pull data out of the database, and the database is automatically decrypting any data that's pulled out of it, what that means is that those credit card numbers get retrieved in clear text. So the system should have encrypted the credit card numbers using a public key when they were being inserted into the database, and then only backend applications would be allowed to decrypt them with a private key. And if we have time, we will talk more about public-private key encryption, but for now, basically understand that one of those keys, the private key, is a key that only you should have, and so you put that in the high-value places. And then the public key is something that's a little bit more convenient, technically public, right? And that can be used to do the encryption and can be put anywhere. So that can be put in a lower security context location. Yeah. So, example scenario number 2. I mentioned Firesheet earlier today. In this case, a site just simply doesn't use SSL for all authenticated pages. So the attacker is basically looking at the network traffic, maybe it's an open wireless network or something like that, and when they see that session cookie go over, they say, okay, I want that. And then they just replay the cookie, and because they have that, the session ID is in there, for as long as that session ID is valid, they're able to access the user's private data. So again, this is the reason why we say, hey, it doesn't matter, right? Every website that's a website on the internet, even if it's like joshsokol.com and it does nothing sensitive, still should be HTTPS, right? Because it's that easy, it's that silly for you not to do it, and you get the boost in Google's ratings. So just a pictorial example of what I just said. In this case, we have sensitive data, we have some user that's processing it with the application, and then we have the little voyeur guy on the bottom who's looking at the wire and sees the sensitive data go across. Example number 3. So let's talk briefly about salts and the way passwords are stored properly in a database. I mentioned earlier the forgot my password functionality where you get the email back that has the password in it. That is a big problem because what that tells me is that password is basically being stored in the database in that format. What we want to do when we store passwords, we don't want to store the actual password at all. We want to store what's called a hash. And a hash basically takes a one-way function, it takes that password and turns it into some random value, right? And now what we need to do is when we want to look and we want to do a password authentication, we've stored the hash in the database, not the actual password. So to see if that user is a valid user, we simply go and we say, all right, the password they entered, let's hash that, and let's compare the hash that we stored to the hash of the password they entered. Match them up, right? Now, the problem that we've run into is that you can create a dictionary of lots of different passwords, and you can hash all those different dictionaries, and you can come up with a list of all the hashes. And this is what we call a rainbow table. A rainbow table is basically a list of all the hash passwords. So now what I can do if I steal somebody's password database and they've hashed their passwords is I simply compare it to the rainbow table of hashes, and you can actually enter a hash into Google and get data back for it. And we'll be able to see, is there a pre-calculated password that matches that hash? Piece of cake, right? So The way that we have fixed this from a security perspective is we've added a value called a salt. And a salt is basically a random value that is stored in the database alongside that user, so it's unique to each user in the system. And when we hash the user's password, we combine their password with the salt value for that user, and then we hash that value. So now we're not hashing a known value, which is that dictionary word. We're hashing the combination of the password plus the salt, which is a random value. And that is the value that we're storing, right? So we're infinitely more secure now because we've added a random value for every single user, and there's no real good way to create a rainbow table to address that. Attackers have gotten smart though. And so what they've started doing is they've started saying, okay, well, computers are fast. So what if we do a brute force? What if we simply go and we enter a whole lot of passwords, and then we see if we can create a hash randomly that matches this hash value that I got, right? Try and figure out what the password is by trying different combinations over and over. And it's comparably easier if I have a copy of the hash table to do that with. So what we've started doing now is we've started using tools like Decrypt, which instead of just doing that hash function once, it does it once, and then it hashes that value, and then it hashes that value, and that value, and that value, and it does it over and over and over again, which ends up being a pretty costly computation. So if you do that 8 times, 10 times, 12 times, for one particular login, that might introduce a few seconds of delay for the authentication. But if you're an attacker and you're trying to compute a decrypt hash, 3 seconds, 4 seconds, whatever it is, for every single possible combination, you've just raised the ceiling really, really high in terms of being able to brute force those values, right? And that's what we've done. Now, Decrypt gives you the ability to tweak how many times you do that hashing function. And I think what we'll see is as computing power gets greater and greater and greater, guidance is going to change on that in terms of how many computations you do, how many of those hashes you do, especially as we move towards things like quantum computing and stuff like that. Questions about that? Cool. So in this example scenario, we have a password database that uses unsalted hashes. We all know what that means, to store everyone's passwords. A file upload flaw allows an attacker to retrieve the password file. So we now have a copy of that file. It has hashes, but there's no salts. And because all of the unsalted hashes can be exposed using a rainbow table of pre-calculated hashes. So here's an example. This was a table that I found online, and basically said with each of these different character sets, so depending on the different characters that you want to hash, this is the size of the file, and this is the success rate at being able to find a value in there. So in the case of something that's in the alpha space with 1 to 9 characters, you have 100% success rate, 99.9%. And the size of that file is just 24 gigs, right? That's super easy. If you introduce things like lower alpha and numerical and 1 to 10 characters, the file size gets bigger, but you still basically have a 100% success rate. The way that this changes is as you introduce more length, more different types of characters, right? And so this is the reason why guidance has changed from use a password, right, 10 characters or whatever, random stuff. We can calculate that pretty quickly for all possible values to things like use a passphrase. Because those passphrases are going to be a random series of words. Every space that you have in there is basically a special character. You can even add in more special characters, things like that. And now you have a long string of words that is significantly harder to calculate or brute force in this manner. Make sense? All right. Here's a fourth scenario. This is the backup tape example, where we had somebody who basically has an application. There's sensitive data that's being stored in that application, in a database, they make a backup of that, but the backup is not encrypted, and so that backup tape goes missing, right? And we've seen plenty of examples in the news where a backup tape went missing. It was something that was, fell off the back of the truck, and the tapes were waiting outside for the driver to pick them up. Whatever the case may be, we've seen a number of examples of that. All right. So, how do we prevent sensitive data exposure? First, for all sensitive data, we have to do all of the following at a minimum. Considering the threats you plan to protect this data from, inside attacker, external user, whatever, make sure that we encrypt all sensitive data at rest and in transit in a manner that defends against those threats. So this is where things like the threat modeling come into play, and we start to look at where is an attacker going to attack us, right? In this data flow, where data moves from this system to this system, is that a place where an attacker can see it? And if so, should we encrypt that data? This gets kind of interesting when we start looking at things like AWS, and guidance is kind of all over the place, because technically when I'm in the Amazon Web Service environment, and I have what's called a VPC, a virtual private cloud, that data only stays within that VPC. And so guidance from PCI is that you can actually not encrypt the data within the VPC, because at least in theory, there's no way for somebody to see that data. Now, me personally, I would much rather encrypt that, use HTTPS, things like that, because it's easy. It's not a difficult thing to do.
Do you use some guidance
For PCI DSS, there's a document called the PCI Data Security Standard. And that is the document that guides us with respect to credit card data security. That is a good guideline in terms of how we protect credit cards. A lot of the things that are in the DSS are considered best practice, and those best practices could be applied to other types of data. That answer your question?
So when you say guide, what's referring to that document?
When I'm talking about the PCI DSS and credit card data, I'm referring to that document. Yeah.
There are more requirements.
Requirements?
It's regulatory control for PCI, that's a federal regulatory control, and as Josh said earlier, or I remember, there's different levels that each organization will adhere to,
Yeah.
depending on the transactions. So those organizations will need to follow at a minimum certain PCI regulatory controls for their organization. So that is a national, federal, people look up on Google, and it's out there.
Yeah. Yeah, so PCI DSS, thank you, it is a actual standard. It's created by the credit card industry, and it basically outlines how they protect, or how the merchant banks and the customers are required to protect credit card data. It came about as a result of all the different breaches around credit card data, and so they finally came up with guidance in terms of how to protect that data. But it is very specific to credit card data. There are other guidelines out there for other types of data, depending on what it is. But PCI, it's a good guideline when it comes to credit cards specifically.
I heard that PCI has a guideline, but I didn't know if when you were referring to guide, whether it was a name of something or whether it was a document or.
Yeah. Yeah.
I think what you're saying is use the PCI guideline as a guide for your planning and making decisions.
Yes. Yeah. All right. Cool. So we're making sure that we're encrypting all of our sensitive data at rest and in transit. Second, don't store sensitive data unnecessarily. Discard as soon as possible. Data that you don't have can't be stolen. This again is why that PCI DSS guideline says that you should get rid of any credit cards that you will no longer be using, right? Because that's a liability. But if you get that out of there, if you purge that data, you're reducing the liability, and any cards that you don't hold, they can't be stolen. Number 3, ensure strong standard algorithms and strong keys are used. Proper key management is in place, and consider using FIPS 142 validated cryptographic modules. So FIPS is the federal standard around security there. And so if you look up FIPS 140-2, this is the standard for data encryption. And it'll tell you these are the cryptographic algorithms that you can use. It'll tell you these are the recommended, or not even recommended, but required things for government level security of data. It'll tell you here's the things around key rotation. So in terms of a standard, in terms of some sort of regulation requirement of how do I do this, FIPS 140 is that standard. That is what I would tailor my organization to, because that is the government standard, right? Questions about that?
About Windows, it doesn't do
So Windows should support FIPS 142 for certain processing.
Windows.
Right. What's that?
Do they still use NTLM too?
I think they do, yes. Yeah. But when you start moving into Active Directory and things like that. I don't know. So number 4, ensure passwords are stored with an algorithm specifically designed for password protection. And again, I mentioned bcrypt, PBK DF2, or scrypt are a couple other ones. They effectively do the same thing. We're making sure that we are taking that hash and we're doing it multiple times over to ensure that it's going to take a long time for an attacker to try and brute force that. And number 5, disable autocomplete on forms collecting sensitive data, and disable caching for pages that contain sensitive data. This is often an afterthought, but when we think about it, if you have a web application and there's a credit card field in that application, if you don't disable autocomplete, there's a pretty high chance that the browser is going to put that field into its memory, and then the next time somebody goes to that page, that is going to be a value in that field, right? And especially in situations where this isn't my computer, this is a shared computer, that gets really hairy really quickly. So we want to disable autocomplete on any of those different fields, and in all likelihood, what we probably want to do is define those fields as password fields or as sensitive fields, so that as we enter it, it's actually going to blank it out on the screen. Caching is important as well, because if you have a caching server like a proxy or something like that on the front end that's caching those pages for performance, if it's caching the pages with sensitive data, that now becomes a potential place where an attacker could go try and get those pages, and now they have access to that sensitive data without having access to the application itself and without authenticating. Make sense? All right. So high-level safeguards, develop a data classification policy if you don't already have it. Data classification policy is basically a policy that says, here's the different types of data that our organization maintains, and here's what we're going to do to protect it, right? And it usually defines multiple different levels, and within each of those levels, the different types of data, and then the controls that you have. Review the information stored in an application against that data classification to determine which fields need to be encrypted. So if our data classification policy says that something like a social security number is a high business impact, and all high business impact data needs to be encrypted, this is easy, right? We just look at our application, we've got a social security number field right here, we know that that's high business impact, therefore we encrypt that data, right? The place where this gets questionable is in cases where your data classification policy does not define that. And that's where you need to be working with your security team, you need to be working with your compliance team, your legal team, to understand any requirements around the data, any regulation around the data, and make sure that you are protecting it according to those regulations. GDPR for us has become a really big thing as our lawyers start to look into it, and we start to hear things like, hey, you guys can't store information about the web pages that an employee visits, because that's a violation of GDPR, that's a violation of privacy, right? And even if I tell them, but I'm not looking at those pages, right? I don't care what they're visiting. I just care if they're going to a bad page that we stop it. There's still requirements around notifying employees of what we're monitoring, how we're monitoring, what we do with that data, specifically with respect to GDPR. The last example here is build or update your application to encrypt those fields when at rest. So we want to make sure that our application, that we understand what these fields are, that we are identifying them according to our data classification policy, and then that we're ensuring that those fields are encrypted. So here's an example data classification policy. This is one that I had initially used, and I've kind of tweaked this since. But the idea was that I had 3 levels. I had a high business impact, moderate, and low. And in the high business impact, you had things like government identification, driver's numbers, social security numbers, passports, things like that. You had financial information like credit card numbers and bank account numbers, and you had health information. These are all highly regulated things, and in all likelihood, if they got lost or stolen, it would be a very big deal. Therefore, that's high business impact, and we encrypt all, right? The second category is moderate. And here we're talking about things like race, religion, political opinions, trade union memberships, even some things like name, address, email, telephone, IP address. And we identify those as moderate impact because in and of themselves, there's no real value to those things. It's not like my race is going to allow somebody to impersonate me. But it is sensitive data. And so we probably have to make a judgment call on those things. Whether or not it's something worth encrypting, right? Whether or not if somebody got a hold of this, it would be worth something to them. Now GDPR, that second category, starts to fall into the high business impact. Because what GDPR says is that anything that is personally identifiable, meaning something that I can track back to a unique person, is within the scope of GDPR. And so things like your address, your email, your telephone number, or your IP address are all technically within scope, which means that we would need to protect that data. The low business impact is effectively everything else. It's publicly accessible web pages, it's public press releases, brochures, white papers, things like that we expect to be public. And therefore, if that data were to be made public, even if we don't necessarily publish it, it's probably not a big deal. Make sense? All right, so let's talk about some implementation level safeguards. So, first thing is we want to use strong encryption algorithms. I would probably strike Triple Dss off this list. It is not FIPS 140-2 approved, I believe so. At this point, we're looking at AES encryption, and at AES 256 at that. So 256 is 256 bit. Along with that is SHA, and SHA is basically the hashing algorithm that we're using. Old algorithms are things like MD5. We should probably strike those off our list. SHA-256 says that we have a 256-bit hash that we're using, which is probably decent, and that is according to FIPS approved. But we've also moved to SHA-512. So if you have the capability to do that in your application, you absolutely should. That said, there are some applications that are unable to process data if it gets too big. So you could run into issues there. The next one is using platform-provided implementations of our algorithms. So I mentioned before, when we were talking about the session IDs, that we use the stuff that's built into whatever platform we're using. And the reason for this is that we have a lot of very smart people who study things like mathematics and computer science and things like that, and they have written those libraries for us. Now, I'm a smart person, you all are very smart people. We could probably sit down and try to write something like this. But our world, our area of knowledge is actually relatively small. And when it comes to things like cryptography, there are subtleties in there that you do not pick up in a normal conversation, in normal study. There's things like initialization vectors and randomness that if you don't get those things right, you get it very wrong. And that very wrong is what we need to stay away from. So in this case, if our platform provides us with some capabilities with respect to encryption, we absolutely should be taking advantage of that. And if our platform doesn't provide that by default, then we should look towards reliable open source libraries for doing that kind of thing. So OpenSSL, as an example, is a really good one to use. The last one here is keys. And we want to make sure that any keys that we have are being stored in a secure manner. And what that means is that those keys are, it's just like the key to your house or the key to your car, right? You don't take that key and set it out on a table and walk away from it. If you do that, somebody's going to take a picture of it and reproduce it, somebody's going to steal it outright, right? But they're going to use that in order to exploit your house, in order to exploit your car. These kind of keys, these digital keys, are no different. We need to make sure that those keys are stored in a safe place. And what that means is that we're putting them in what's called a key store, which is basically a secure encrypted database of all of our keys, or some other secure facility like a HKM, a hardware key manager, or something like that. In terms of Java-specific safeguards, you can use JCE, which is the Java Cryptography Extensions, and they have a JCE key store that you can store keys into. Protect the key store with file permissions so that you're ensuring only the right users have access to that data, and then using a passphrase for the key store whenever possible. So we're narrowing the scope, narrowing our attack surface so that very few people will be able to get at that data. Make sense? Yeah.
You said reliable open source libraries were available for but what about Ruby and regular JavaScript?
Those are just examples. There are libraries that are available there, and I'm pretty sure OpenSSL, there should be some iteration of OpenSSL for each of those. That's at the top of my list in terms of reliable open source libraries. Say that again. Bouncy Castle. Thank you. Yeah, that's another good one. It's a funny name. Yeah. All right. Other questions?
Where's Java deserialization fit on this? I know they put it on 17.
Yeah. Dan, do you want to talk about Java deserialization? I feel like
We pulled some stuff together. I pulled some stuff together on the XML entity expansion.
okay.
I don't know what time.
We'll see if we have time to cover that now. All right, so quick recap. Occurs when applications don't properly protect sensitive data, and we want to prevent it by encrypting sensitive data and resting in transit. We don't want to store sensitive data if we don't have to, and then using strong encryption algorithms and keys. Again, FIPS 142 is a good standard for that, and lots of references. OWASP cryptographic storage cheat sheet is a good one. There's a password storage cheat sheet. There's a TLS protection cheat sheet. So lots of good data. Again, like I said, Google OWASP cheat sheet and whatever you're looking at, and chances are pretty high that there's a cheat sheet out there to help you with whatever you're trying to do. All right. This seems like a really good time to take a 10-minute break, I think. So let's do that. It is 2:47 right now. We'll come back at 2:57.
No, I was looking for you at the lunch break, but you were gone. So this is Sean. We go back many lifetimes ago. Right. It's in my son's 18, so it's 20 years. Wow.
So you're in transit, probably not here. I would say that they say they can't do it online, right? But if you have the keeper grip with us, it means you can keep the data, which means that you can bring the data in, right? So, exactly, yeah, I mean, you could, yeah, you're right, you could basically say, all right, let's AES encode the interval, that's it. Yeah, exactly. So, it seems more like a laziness thing or a prioritization thing than a, you know, core. Yeah, yeah. It's like, so.
Think about it in this way that on the assessment architecture side, it'll always kind of be at the beginning of a project identifying design requirements, security requirements. And if they ever decided they're going to go live with that, we would know the findings. So I'm now like way after that to the point where anything that's already been identified as a finding, whether it's from security assessment or now I'm getting more into like quality stuff now too. I do the best I can to help.
So it's like post-production.
Let me explain this one to you. Right?
So I have to work with this guy.
Let me explain this one to you. So a few months ago, he used to backstab me by finding out all these vulnerabilities in my application and make me fix those. Now,
If they could be found,
hold on. Now he's on the other side of the wall, and now he has to fix all of those.
That's much more fun, right?
I like it. It's
Yeah.
using a different part of the
I
security
mean, you want to
mindset.
go, you should like it.
Yeah. So it's like still very security heavy,
Right.
but it's just like instead of the design consultation or analysis of whether it's compliant or not, it's everything after now. Okay, we know the problem. How do we fix it? How do we reduce the risk? So yeah, I like it. Different part of the security brain. Things with you.
Things are good.
I feel like every time I see you, you have a different look going on.
Yeah, everyone says that. I try to change so many things that changes. So, try to take it. Yeah, back in summer, I was like, full guard, now it's weather is good. So, I always like this.
Yeah.
Being messy sometimes looks good.
Like you should do it like.
I mean,
He is my beard inspiration already.
yeah, well, this is,
That's out of scope now.
yeah, it really is.
Beard is, you play, we wear the beard bonds. Yeah.
Maybe it'll just get long enough that I just,
Yeah, like patted. Grab some coffee.
yeah.
All right, everybody. Any questions about anything that we've been through so far? All right. A lot of material. Number 7, the OWASP Top 10, A7. Missing functional level access control. So this is one of the trickier vulnerabilities. We've talked about the technical vulnerabilities versus logical vulnerabilities. With the technical vulnerabilities being typically related to coding flaws and the ones that are often easy to find using automation, either dynamic testing or static testing. This is one of the trickier ones where it's more of it's a logic flaw in the application, so that makes it more challenging to find. So these access control flaws occur when a web application fails to check on the server side, fails to check that a certain function should be able to be performed by a certain user. A lot of web applications are good at not rendering user interface elements that aren't appropriate for a user to access. Right? And that's the type of stuff that you can catch during QA to say, if the user should be able to see an admin page, let's check to see if this user is there and not render the link if they're not supposed to have access. Or similar, if there's other user interface elements, let's check the user's role, their capabilities, and determine whether or not we want to render that piece in the user interface. The trick is that that's not enough. Just not showing a link on a given page doesn't mean that someone can't craft an HTTP request that mimics what that request or whatever request would look like to access that. And so if you're not checking on the server side that the current user is, first of all authenticated, but then authorized to perform a certain function, you run the risk that the malicious users are going to identify this functionality and try to access it without proper authorization. So the impact of these varies, again, depending on the functionality. So what's bad about this is it's going to allow users to access unauthorized functionality or functionality that they are not supposed to be authorized to have access to. Administrative functions of applications are key targets for this kind of attack. So you really need to consider the business value of the functions that are available in this particular application to determine the risk of the exploit of this type of vulnerability if it's been identified. These are also the type of embarrassing things from a reputation standpoint that that you don't want to have out there, you don't want to have associated with your organization or with your brand. So what you need to do is you need to know, what are the different functions that we have available in this application. And first of all, are we going to see the user interface to navigate to these things? Again, QA typically finds this stuff. It's not going to render parts of the user interface that would give you access or that would make you think that you could have access to different parts of it. But the real important question is, are there server-side authorization checks to access this type of functionality? What comes after that is, are these server-side checks done based on your server-side session state, or are they done based on parameters or something that is passed in by the user? Again, you can't trust anything passed in by the user. Get parameters, post parameters, access to given URLs. So, bad guys can craft requests that have that set arbitrary values to these things. And so a really interesting. This wasn't a web application. This was it was a thick client .NET application. And the way that it worked is, when you logged into the application, you got you got some sort of a yes or no code, and as well as a set of user permissions that you were supposed to have. They got sent down to the thick client. So the thick client in this case is essentially a browser, right? Because it's something running on the user's machine. The user has control over that. And it would render parts of the user interface, buttons and like buttons you can go to other screens or to submit different information. It would render that based on the profile, the user profile that was set down to that thick client. The problem was that that's the only place that those security checks were made, were on there, in that thick client that ran on people's Windows workstations. And so what we did is we took the application, we decompiled it. We talked about that a little bit earlier. It was a .NET application, we decompiled it back to source code, and we altered the part of the system that did the security checks just basically to always answer yes, right? I think there was some talk earlier. With cookies, admin equals 0, just flip that, admin equals 1. It was a little more complicated, but that's what we did. We essentially changed the system so that the code running on the client machine would always just say, do I have this permission? Yes, you do, right? And in that case, it popped open for us all of the administrative capabilities in the system, and we were able to use our modified thick client to access any capability that we wanted on the server side, because they only had these authorization checks in the thick client that ran on the client side. There were no server side checks to make sure, hey, have you been properly authenticated, and more importantly, is this particular user that's been authenticated, do they have authorization to perform these functions? So again, the same problem you see in web applications. In this case, it was a .NET thick client application that ran on people's workstations. But the same basic situation, which is the concern that you need to have of the capabilities and the functionality that I'm writing into my application that I expose on the server side. Do I have server-side based checks to make sure that this user should actually be able to do the stuff that they're doing? How can you test or check for this stuff? One way to do this is to log in to your application with a privileged role and crawl the application. Let's find out what are all the URLs that you have access to in the application, and what are the parameters that you can pass in. So you can use a tool like OWASP Zap. On the open source side for OWASP, you can use Burp. There's any number of other proxy tools, but that let you surf through the application, crawl through the application to identify what are all the links that we can get to as a privileged users, and what are all the parameters that can be passed in. Given that set of URLs that you can see and the parameters that you can see to pass in, log in then as a user with with fewer permissions, right? And crawl the application again and check the difference between these two things, right? Because this is the difference between what a privileged user, an administrative level user, should be able to see to your application, and you can compare that with what a normal user is able to see. Now, if you then go through and for all the URLs where that you could see as a privileged user, but you didn't see as a lesser privileged user, see if you can go visit those pages, right? So you can check to see, are there proper authorization checks on the server side that says this less privileged user is trying to view this page or is trying to view this function. And that'll let you know, is there actually a server-side check for this, or is the only reason that this less privileged user didn't find that URL in the crawl or didn't find that parameter in the crawl was because it was just never rendered in the user interface, right? So that's one way to go through and check from a dynamic standpoint or from a testing standpoint. You can also flip that around and look at how you're doing authentication and authorization in the application code. That's something that when you're, if you look through and do a code review to look for sensitive functions, you should have checks in there that identify, just like Josh talked about from an insecure direct object reference standpoint. Before I let this user look at document ID number 7, well, I probably need to make sure that that user is actually, is actually authorized to look at document ID number 7. Similarly, you can look at access to these sensitive functions on the server side to see from a code level standpoint, are there checks in there that actually say, before I run this function, let me make sure. Let's take a look at the current logged in user. Let's take a look at their session and identify the roles they're supposed to have and how that user is configured to make a determination. Does it look like there's actually a check in place that is going to prevent an unprivileged or a lesser privileged user from getting access to this, to this type of function? And again, the challenge here is that automated tools aren't really good at finding this type of problem because the automated tools don't necessarily understand what the business rules are surrounding your application. And so there's things you can do with automated crawlers that can give you information to show you, which URLs do I have access to, which parameters does the application think it can pass in. But making a determination to say, for these URLs that should only be seen by administrative level users, do I have access, or what does the application do when I try to go there as a lower privileged user? Again, those are the types of things that, typically as a human you have to go through to make a determination of, should this user actually be able to see this, or should this user not be able to see this particular part of the system? That's going to boil down to a question for this application, for the business rules surrounding the system. It may or may not be acceptable that this user is able to get to this area. So example scenario 1, an attacker is going to view the system. Maybe they're not logged in, maybe they're logged in as just a normal user in the system, and they're going to try to force browse to different URLs. And so they can, by force browse, I mean basically to construct a URL, either in the URL bar or to craft a get or a post request, where you're trying to go directly to a specific part of the, a specific part of the application, where you're not clicking on a link or where you're not being brought there by the navigation of the, by the system itself. And there's a tool, I don't know how well it's been maintained, but there's a tool called Durbuster that basically has a great set of, URLs or directories that you can try to force browse to, like admin, /admin/reports that had a great list of things like that that you can use to identify, hey, for the stuff that I can find in this application, let me see if for the stuff that they're willing to show me in this application, let's see if there's additional stuff that we can find beyond that by guessing at these URLs, and let's see what the application shows us for each of these URLs. And again, this is something where you can use automation to go through and crawl to grab these pages. It typically takes a human to go through and look to see, if I've got an unprivileged user going to /admin, does it give me a page that says, this is the admin page and you don't have access, which would be correct? Does it give you a list of all the files in that directory? That would be less correct in a lot of cases. Or does it just render some sort of an index page for the admin functionality where it's got things open and available to you? That's a really bad sign. And so This is the type of thing where attackers use a combination of automation and their manual inspection to identify, does it look like this web application has these types of issues. Another scenario that we've seen, that we've seen in a number of cases is if you have applications that route all the traffic through one sort of a routing servlet or a routing page or something like that, where you say, I'm going to take an action. Is my action going to be to add an item to the cart? Is my action going to be to start checkout? Is my action going to be to finish checkout? You guys may have seen applications like this. You may have built applications like this, where again, all the requests come into some central page. You pass in an action parameter. That then the application then makes a determination. Okay, I'm going to look for other parameters, potentially do some stuff, and then I need to render another page. That's something that we saw more frequently. If you look at the WebGoat application, that's how the WebGoat application organizes its URLs. I know we've built applications like that, or I've built applications like that previously in my career. We've seen a lot from a testing standpoint. The risk there is, that again, from a user standpoint, you're probably seeing some subset of the actions that you can take. Again, from a normal user, register, add item to cart, checkout, checkout 1, checkout 2, checkout 3, finish checkout, what it might be, view order. So there's probably some set of actions that, as a normally privileged user, you're supposed to have access to. But there may be other actions that you shouldn't have access to that you would only see if you were logged in as an administrative user. That's another thing. Again, if you have administrative credentials, you can go through and enumerate those. Those are also the type of things you have source code access. Look at the way the URLs are crafted, or the switch statement that the routing servlet uses, and identify. Here's the set of actions that I was able to identify that seem to be valid values. But looking at the source code, here's an additional set of actions that are potentially a superset of what I was able to see before. Those are the types of things from a testing standpoint you can then either dynamically try to route to those actions to see how the application behaves, or from a code inspection standpoint, you can go and look to see, well, for this switch statement for this action, if it's a sensitive action, where is the code-based authorization check to say, is this person logged in? Should this person be able to take this, this particular action? And should they be able to do it for this particular data that's in there? And so those are, again, two kind of common patterns that we see when testing for these things are doing forced browsing to directories or to URLs when we're trying to guess at the names of pages or URLs that the application will respond to, or in a situation where you have some sort of a routing mechanism that sends you out to different part of the applications, making a determination of what those are, and then either trying to guess at additional actions or given access to the source code or given administrative access to identify the difference between what an administrative user can see or should see and what a normal user can and should see. And so, just as how these types of vulnerabilities can be challenging to find because you can't get a tremendous amount of automation support for them, it's also hard to give developers blanket guidance to get them in a consistent way to avoid these types of issues, really. Because really what it comes down to is making sure that developers understand the concept of authentication. They understand the concept of authorization, right? So that they know, hey, users need to be logged in order to access certain functions. So let's make sure that we've got the appropriate checks in place, preferably enforced by the web framework. Again, any situation where you can use the built-in web frameworks and their access controls to at least provide a first line of defense, that's preferable because that code typically is going to be better thought out than anything you're putting together at the spur of the moment, and it's going to be more eyes are going to have seen it and done testing on that to make sure that those controls work in place. Similar to crypto, similar to session management, this is an area where, from a platform standpoint, to the degree that they have controls in place to do this, you certainly want to use those unless you have a really compelling reason not to. And almost all of these so-called compelling reasons that developers have come up with have not been nearly as compelling as they may have thought. And so you first have to get the developers thinking about authentication and understanding what platform controls are in place that provide those authentication controls. But you also need them to understand the concept of authorization, which is given that I know what user I'm talking to, what action should they be able to take in the system, right? What records should they, or what data should they be able to see in the system? And this is the type of thing that doing threat modeling can help to identify, right? To talk through with developers, hey, from a structured standpoint, what does this system do? How do the pieces fit together? Let's talk about ways that attackers can potentially make this application do stuff it's not to do. This is really a really useful practice to have in place for for development teams. It's something you can do on whiteboards. It's obviously better to have a more structured approach, but it's going to be a great set of conversations. And also using abuse cases, right? Now, how many people here are familiar with use cases, agile development, user stories, things of that nature? All right, to flip that around and say, we've talked about what the system is supposed to do. Let's also talk about ways the system might be abused, right? And to talk through, well, what if a normal user tries to view the admin page, right? They say, oh, well, we won't render the link. Like, well, that's a good first step, but what check do you have in place on that admin page to make sure that anybody who magically gets there or wanders into that location is not able to get to see the rendered page? So those are great conversations to have with developers to say, from a use case standpoint, we know what this application is supposed to do, right? Or we know what this use case is supposed to do if it goes on the happy path. But let's also talk a little bit about how we can be taken off the happy path, or how a malicious user might try to exploit or misuse this functionality for some sort of gain. And that's going back very much to what Josh talked about early on, right? You've got your requirements of what the system is supposed to do, but what gets built is, doesn't completely perfectly overlap with that. And you've got stuff that the system's not doing that it's supposed to do, and those are bugs, but you also need to have developers at least thinking about what could the system be made to do that it's not supposed to do. And one way of eliciting that type of thinking from developers is to talk through this concept of abuse cases, right? Or how could this be used in a way, made to do something that it's not supposed to do? Ideally, also, this is something that is hard-coded. Again, if you can use the platform-level controls for as much of this as possible, that would be that is certainly preferable. And the enforcement mechanism, again, your preference is going to be to deny all by default, and to have somewhat fine-grained rules for what specific capabilities users should be able to access. Again, but this requires thinking about this up front from a permissions, from an access standpoint. What are the different classes of users we have in their roles? What should they be able to do? And also an area where we found problems in the past is in workflows. If you have multiple multi-step workflows, right? Like a checkout process, for example, right? You go to checkout, let's make sure we've got your user information, now enter all of your billing information, now enter your shipping information, now confirm that you want to complete your order, right? Looking for situations where we can go, let's go to the first step of the workflow, and then let's jump to the third step, and let's see if we can make this application do something that it's not supposed to do. Do you have the appropriate checks in place to say, hey, if we find ourselves at the finalized part of the process, do we have those three previous parts of the process, right? Or if we're collecting our shipping information, do we make sure that we've got the user information, we've got the billing information, or whatever the user, whatever the workflow is in your particular application, those rules, checking the user, checking the state of that user, is something that you want to design into the systems so that if somebody goes to step 1 of the workflow and then jumps to step 4, we're going to trap that and we're going to bounce them back to step 1 or step 2 or where it's appropriate for them to be. Again, going back to talking about when we look at the fail open or fail close systems, being explicit about how we want the system to behave under unsure circumstances. To be explicit about that up front pays security dividends down the road, because then you have the way that the application is supposed to behave, and you should not be surprised by any behaviors that you see later on. In the Java environment, again, we talked a little bit about some of the access control stuff in Java. This is usually more web framework related, where you can force authentication, you can force authorization, and again, Java has their authentication authorization services that can help you plug into different data stores. LDAP, Kerberos, and whatnot, depending on what your application architecture looks like. Usually a better question is to ask about the web framework you're using. If you're using Ruby on Rails, if you're using Spring, what are the specific capabilities of the web level framework? The Jas stuff is usually tied more back into enterprise infrastructure as opposed to like customer-facing line of business web applications. So to recap, these types of the issues occur when your application isn't performing access control checks on the server when each function or capability is being accessed, right? So it's not a question of are we rendering this for the client side or any sort of controls you have on the client side. The question is on the server when you get a user request, before you actually perform some function, are you performing the appropriate authorization checks? And this is the type of thing that can be prevented by providing the platform level controls to and making sure that the developers understand here's how you perform authorization. Here's how this gets encoded into the application. Here's how the configuration for this looks, and then that gives you a way to check to say, hey, let's talk about authorization. Show me how you've configured access control to these different pages. Show me how you've controlled access control to these different modules. Hopefully that's something that the developer can enumerate to say, here are all the sensitive access control situations that we have, and we can run through and show, like, these are blocked at this level. We have code checks for these because they, the platform level stuff wasn't granular enough for what we wanted to do. And again, depending on the web framework, this is something that either appears in a central location, some sort of a routing database, or it's something that grepping through the source code you can identify, hey, what's the construct that talks about the authorization control or about the URLs? Okay, well, let's grep through the code, dump out the list of these, and then we can run through to identify, do we actually have server checks here? If you're using commercial static analysis tools, this is also something that we've done where you can create you can create specific rules to say, show me everywhere in the code that we're doing something where we want to have an authorization check, either to give me a list of things that I can check for, or and depending on what your what the rules look like, ideally to say every time I see this, I should also have this type of authorization check, and that's something that we've done in the past as well. Again, it can be done quick and dirty with something like with a tool like grep. It can also with the commercial static analysis tools, you've got the ability to potentially write different rules for how to analyze the source code. A couple of different resources that are out and available there. The CWE entry looking at the improper access control for authorization. They talk broadly about this. Also some resources from the from OWASP in different areas looking at forced browsing, URL access. And again, a challenge with a vulnerability like this is it's not just one thing like SQL injection where you can say, I want to look for the specific situation of am I mishandling data that's being passed into the application and passed to these sensitive SQL functions, right? That's at least a kind of a cut and dried something to put a box around. This is asking more conceptually about your application. Do you have the concept of authorization implemented? Did the developers understand and have they applied those authorization checks consistently everywhere that they should? And so again, that's an unfortunate thing about this, but by looking at this from a couple different angles, from the URL access, from the platform, the web framework, authentication, authorization controls, you can identify how do we triangulate so that we can get a decent feeling that we have identified the potential situations where we could have done this wrong. And we've identified, and we've gone in and been able to do checks either through dynamic testing or through code inspection to determine that these vulnerabilities, that we've actually identified these situations and have appropriate controls in place. Now, any questions about this, the missing checks, server-side checks for authorization? Excellent. Josh, you want to come up and talk about cross-site request forgery?
Good news, guys. We're on slide 145. Yes. Only 57 slides to go. Not a joke. All right, so let's talk about cross-site request forgery. This is honestly one of my favorite ones to talk about on this deck. This one's super exciting, and I've got an awesome example for you guys of where things can break down in like the worst possible way. So, what is cross-site request forgery? This occurs when an application is susceptible to forced background requests from the users. The attacker uses a combination of cross-site scripting, which we already learned about, along with poorly implemented server-side functionality. And the cross-site scripting payload causes the authenticated browser, one that you've already signed in, has a valid session, to make unintended requests. The server-side code thinks that you were that user, and so it processes the request as if they came from that user. The impact here is going to be moderate. The attackers can trick the victims into performing any state-changing operation that the victim is authorized to perform. So you're basically leveraging the logged-in credentials of that particular user. And examples could include things like updating account details, making purchases, log out, and in some cases even log in. So here's an example. In this case, we have a user. That user is logged into their banking website. And while they're on their banking website, they maybe receive an email or something like that, and it says, hey, go to this site. So they go to that site. That site recognizes that there is a cross-site request forgery vulnerability in the banking website. And when they visit the site, it says, go ahead and use your logged-in credentials on that bank to transfer some money, right? And because the user's browser doesn't understand that this is not the same, this is not the attacker making them make this request. This is the actual user making the request because it's coming from their browser via their logged-in session. The request actually happens, and the money would be transferred. Now, just like cross-site scripting that Dan told you guys about earlier, you have stored cross-site scripting and you have reflected cross-site scripting. You can have stored cross-site request forgery and reflected cross-site request forgery. It can use either GET requests or POST requests. So lots of variation, lots of variety here. So how do we test our applications? The obvious place is to start by looking for cross-site scripting flaws. So we'll look at our applications, and we already know that we can use dynamic analysis tools, static analysis tools, and we can find those cross-site scripting flaws fairly easily because there's that distinctive request and response pattern. Right? I send data in, the data that comes out is not there's no input validation, there's no output encoding. So our scanning tools should be pretty good at finding this. Now, once we realize that there's a cross-site scripting flaw, now we can look at the impact of that cross-site scripting flaw. How much HTML or JavaScript can be injected and where? The more JavaScript that we can inject, the more we can craft a custom payload to take advantage of that. And then, lastly, we want to look for how server-side functionality has been implemented. So could our cross-site scripting payload make a request that would exercise that functionality? Crafting a CSRF payload is very similar to a cross-site scripting payload. You still have to deal with pre and post HTML, and the most basic attacks are going to use GET requests. So think of things like an image source tag, a script source, a link, like style sheet tag. The interesting thing about each of those things is that your browser doesn't really do a check to verify that that tag is for the same domain that's being served for. In fact, it's the opposite, because you want to be able to get images from some other location on that page. So when you do an image source equals and then you load something else, it loads within that context, right? And another interesting thing here is that just because it's an image tag doesn't necessarily mean that an image is the thing that's going to be served. So we can specify for that source a non-image. It won't render as an image, but the request will still be made for that particular resource, which is exactly what we're taking advantage of here. You can also use post requests. Again, that depends on the cross-site scripting. It depends on the amount of data and how we can store it. But if you can make large post requests, you can use XHR objects in order to do that. So, mitigations here. First, protect yourself against the cross-site scripting vulnerabilities, right? And that means positively validating our inputs. Dan talked about this earlier. We want to look at length, type, syntax, and business rules around it. And it means encoding our application outputs. So if we have something like a less than symbol, it should become %LT, greater than %G. Okay? Then we want to design sensitive server-side functionality with protection in mind. And so preferring post request to Git helps here because we're kind of narrowing that scope. You would need a much larger post to make these XHR requests, or you would need a much larger place to store it, less validation, versus a Git request. So if we prefer post to Git, it's going to help. The only thing that actually fixes this problem is what we call a nonce, or a random token. And the nonce is basically a random value that we are going to insert into our request. And we're going to validate that that nonce is the same when we receive the request than when we generate the page that's going to serve up that request. The last thing here is requiring reauthentication for sensitive transactions. So we want to say for things like changing a password, we want to reauthenticate before doing something like that. So in terms of post versus Git, it's comparatively easy to force a browser to make Git requests versus post requests. We talked about crafting payloads. There's lots of injectable tags which cause the browser to make a Git request. And I showed you some examples with script tags, style sheet tags, and so on. Preferring post versus Git, like I said, that's not enough protection alone, but it helps reduce exposure, and it's part of that defense in depth approach we talked about this morning. In terms of the nonces, we want to have session or page-specific random tokens that have to be passed with the request. These are generated using good crypto, so SHA-2 family of hashes, and good randomly generated values that are only known on the server side. And the idea with these nonces is that we're creating tokens that only our application knows about, and that an attacker would not be able to spoof. Because we want to make sure that when that application says go ahead and transfer money, they don't have this value. They don't have this random token. So you can see an example down here of a form that's that transfer form, but now we have a hidden field that we're passing here, and this one has a random name and a random value that we would then validate when this transfer request happens. And if this hidden field is not being provided with that request, we reject it. Because it did not come from that user, it came from something else. Only that user should know that request. And in terms of requiring reauthentication, sensitive operations should be a multi-request process. We want to require the user to represent their credentials. And then if we can use out-of-band facilities to confirm. So email or text message, did you do this, press 1 for yes, or whatever, right? All those things are going to help because the attacker should not have control over those resources. In terms of Java-specific safeguards, we can avoid using those tags because those guys don't encode outputs. Instead, we want to make sure that we're escaping the special HTML characters. So that's things like less than or greater than, single quote, double quote, slash, ampersand, those kind of things. And as Ann mentioned, we want to prefer our whitelist input validation to our blacklist, right? Because we don't want to say no less than, no 1 equals 1, because there are ways that an attacker can get around that. We can use the URL encoder class to encode characters that are being put into a URL, and we can use struts, output mechanisms, or GSTL escape XML is true to encode that data for us. So this is where it gets fun. Everybody understand where we're at right now. We've basically taken advantage of the cross-site scripting flaw. We are using that in order to make a request, using the user's already authenticated session to do something bad. Everybody with me right now? Okay. All right. So that's the fundamental piece. to get to the good part, which is the MySpace worm. Anybody ever hear of the MySpace worm? Maybe a few people. So this was based on an assembled JavaScript that was built from several different substrings. Those substrings bypassed numerous negative filters against malicious tags, attributes, etc. So again, there were blacklist filters in place, and the person who created the MySpace worm, Sammy Kamkar, he was able to figure out how to bypass those blacklists. Right? It relied on the same functionality being served from multiple host names. So in this case, there was profile.myspace.com and www.myspace.com, but the same functionality was across both of them. It used a multi-step background combination of get and post. So the process runs something like this. Get the list of friends, parse out these special post tokens, and then add Sammy as a new friend. And basically the way that this looked when Sammy first posted the MySpace worm is it was just in JavaScript where if you visited his page, it would add you as a friend, or would request that Sammy add you as his friend, and then you would post that same code to your page, basically so that anybody else that visited your page would also request that Sammy's your friend. Sounds relatively harmless, but Sammy kind of breaks it down like this. He says, if I can become their friend, if I can become their hero, then why can't their friends become my friend, my hero? I can propagate the program to their profile, can't I? If someone views my profile and gets this program added to their profile, that means anyone who views their profile also adds me as a friend and hero. And then anyone who hits those people's profiles adds me as a friend and hero. So if 5 people view my profile, that's 5 new friends. If 5 people viewed each of their profiles, that's 25 more new friends. And after that, well, that's when things get difficult. The math happening. So on October 4th, 12:34 p.m., Sammy had 73 friends. And he said, I decided to release my little popularity program. I'm going to be famous among my friends. An hour later, at 1:30 a.m., he says, you have 73 friends and 1 friend request. One of my friend's girlfriends looks at my profile. She is obviously checking me out. I approve her inadvertent friend request and go to bed grinning. 7 hours later, he wakes up, 8:35 in the morning, and he has 74 friends and 221 friend requests. Whoa, didn't expect this much. I'm surprised it even worked. 200 people have been infected in 8 hours. That means I'll have 600 new friends added every day. Whoa, right, no big deal. An hour later at 9:30 a.m., 74 friends and 480 friend requests. Oh wait, it's exponential, isn't it? Shit. An hour later at 10:30, 518 friends and 561 friend requests. Oh crap, I'm getting messages from people pissed off that I'm their friend when they didn't add me. I'm also getting emails saying, hey, how the hell did you get onto my MySpace? Not that I mind, you're hopping from guys with more girls than guys. This actually isn't so bad with girls around. 3 hours later at 1:30, 2,503 friends and 6,373 friends requests. I'm canceling my account. This has gotten out of control. People are messaging me saying they've reported me for hacking them due to my name being in their heroes list. Man, I rock. Back to my worries. People are also emailing me telling me their IM names so that I'll chat with them. Cool. Back to my worries. Apparently people are getting pissed because they delete me from their friends list, view someone else's page or even their own, and get reinfected immediately with me. I rule. I hope no one sues me. 5 hours later, 6:20 p.m., I typically go to my profile to view the friend requests. 2,503 friends, 917,084 friend requests. I refresh 3 seconds later, 918,268. Refresh 3 seconds later, 919,664. A few minutes later, I refresh 1,005,831. It's official, I'm popular. I've hit 1 million plus users. In less than 20 hours, I've hit over 1/35 of all MySpace users. Every request is from a unique, living, and logged in user. I refresh once more and now see nothing but a message that my profile is down for maintenance. I messed up, didn't I? I'm now more afraid and decide I'm never doing anything even near illegal ever again. To get my mind off of everything, I begin downloading a copy of the latest Ectopic episode. An hour later at 7:05, a friend tells me that they can't see their profile, or anyone else's profile, or any bulletin boards, or any groups, or their friends' requests, or their friends. Nothing on MySpace works. Messages are everywhere stating that MySpace is down for maintenance and that the entire MySpace crew is there working on it. I ponder whether I should drive over to their office and apologize. Another attempt to free my mind of worry. I go back to watching some episodes of the OC, which I downloaded a few days earlier. File sharing rocks. 2.5 hours later, 9:30 p.m., I'm told that everything on MySpace seems to be working again. My girlfriend's profile, along with many, many others, still say Sammy is my hero. However, the actual self-propagating program is gone. I'm relieved that it's back up, as they can't claim damages for any downtime past the second, if everything is in fact working properly. 10 minutes later, 9:40 p.m., haven't heard from anyone at MySpace or Fox. A few minutes later, my girlfriend calls, I pick up, and she says to me, "You're my hero." I don't actually get it until about 3 hours later. So, Sammy word in action, something like this. Basically, it would take that code that he wrote. It would effectively say, for anybody who viewed that code, it would say, add Sammy to your hero list, add Sammy as a friend, and then post this to your profile. Pretty simple, but the end result is this worm that propagated across over 1 million profiles in less than 24 hours. Hugely popular, right? Huge, huge impact for something like that. So, in terms of lessons learned here, input validation, positive versus negative wherever possible, right? Dan talked about this earlier, can't stress this enough. Interpretable HTML is a really big place. So if we're trying to carve out a couple of tags and say, yeah, don't allow those things, it doesn't remove the ability of an attacker to find workarounds, as we saw with Sammy. Be careful about what functionality is available and from where. Gets versus posts, what applications are available from a given host name. This is similar to checking to be sure that HTTPS content is not available via HTTP. Right? So, the recap here. Cross-site request forgery vulnerabilities allow attackers to force the user's browsers to undertake actions they don't want or even know about. In the case of Sammy, that action was the action of adding him as a friend, adding him as a hero, posting this to their profile. They didn't know about that, they didn't authorize that, but it used their logged in valid session to do it. There's several varieties. You've got stored and reflected, you've got gate and post. In this case, it was stored. Right? It was stored within their profile. So when somebody browsed it, they immediately got hit by that code. And to guard against it, we want to eliminate the cross-site scripting vulnerabilities. We want to prefer post to get. And we want to use random tokens or nonsense. And that is the only thing here that's actually required to address the issue. Questions? Fun? Everybody likes hearing about Sammy? So, in LastCon 2010, our very first LastCon conference, Sammy was here. He was speaking with us about how I met a girlfriend. Great talk. Sammy is a super cool guy. I've met him a number of times. Really, really nice guy. The end result of this was that he had feds basically kicking in his door early in the morning at gunpoint, stuck him on the floor, took him off to jail, and basically said Sammy was not allowed to touch a computer at all for a very long time. It was like 5 years or 10 years or something crazy like that. Today, Sammy is a security practitioner. He is involved in the community. He's actually done, I think the last thing I saw with him was a car hacking thing they had done. I think there was something where he was doing some drone stuff. If you've ever heard of the website Fiverr, that's something that Sammy created. So still very much involved in this stuff. But it's an interesting story, right? It really shows even somebody like that who he didn't even want to be, like, his intent wasn't malicious, it was curious, right? It was somebody who just wanted to see what would happen and never expected that to happen. It's a really good insight into that mindset, right? So, references, lots of OWASP stuff for CSRF, cheat sheets and whatnot. I would take a look at that. So, we are making progress. OWASP Top 10, A9, using components with no vulnerabilities.
All right. So we talked about this a little bit before when we talked about the security misconfiguration. But this is, because the OWASP Top 10 is app security focused. This section goes in a lot more specific, or a lot more in detail about this. And because when you look at applications that you build, like a huge percentage of the code that is included with your build is probably not code that your developers wrote. Or it's probably a lot of open source libraries that got included. That's all well and good, but you probably only use a subset of that code. But nevertheless, it's an important part of the application that you're constructing. One of the, because it's code, because it's written by humans, occasionally it's written by Bitcoin mining malicious humans, but hopefully it's just written by normal humans that are making normal mistakes. Because of that, this code can have vulnerabilities in it. And so a concern is that when you're including code that you don't control, even if you do everything correctly, you may be calling in the libraries that have functions that have security vulnerabilities in them. And so what this vulnerability looks at is the use of components with known vulnerabilities. And this was a relatively recent addition to the OWASP Top 10 with this list. And so this occurs when you have components such as libraries, frameworks, or other software modules that are included in your application. And they are typically, unless you're doing something really weird, they're going to be running with the same level of permissions as your application. And so if you have the component that has a vulnerability in it, that vulnerability is going to run with the same permission as your application, just like code that you would have written. And that could potentially facilitate serious loss, server takeover, again, up to the limits of whatever the vulnerable code that was included there. And so having these components in your application that have vulnerabilities in them can undermine other defenses that you may have in your application. Again, so even if every line of code that your developers write is perfect, which is not super likely, by including a whole bunch of code from other folks, you're exposing yourself to a significant amount of risk. I had a conversation with Joe Drzambek he was formerly with DHS, and this is something he's paid a lot of attention to, looking at the software supply chain, right? Where do you get the code that goes into your applications? You're writing some portion of it, but you're also potentially connected to the NPM for node modules, to Maven for Java components and whatnot. He really spent a lot of time looking at this challenge, or the challenges associated with the software supply chain. Where did this code that we're running come from, and what are the security and other properties of this code? Again, impact here is the full range of potential weaknesses is possible. It can be injection flaws, broken access controls, cross-site scripting, again, up to the limits of whatever that code is doing in your application, whatever stuff they're doing for you, they could potentially be doing it wrong. And again, so the range of the impact of these errors is pretty variable. And as we've discussed a little bit leading up to this, just because a component has vulnerabilities in it doesn't necessarily mean that your application is vulnerable, right? So that's something to be wary of when you hear statistics from different folks, usually vendors selling solutions, where they'll say, like 90 million% of applications or you have a component with at least one vulnerability in it. Probably true, right? what is the impact in your environment? Well, that's the greater question. That's the bigger question that you need to look at from a risk management standpoint. So how do you determine if you're vulnerable to using components with known vulnerabilities, right? Well, you need to have an inventory of the components that you are including in your application. With more modern applications, the good news is most of those use systems like Maven or NPM to manage their dependencies. And that's good because then you have a structured way to say, I'm using a component, I'm using this version, it has dependencies. When I build my application, I can watch the thing go and pull all the stuff and determine, okay, well, here's all the components that we pulled in that are now incorporated into this particular build of the software that we have. This is a little bit riskier if you're doing C and C++, if you're cutting and pasting a lot of code or including libraries that gets rolled up. If you don't have a package manager managing this for you, that can be more, it can be more challenging to make a determination of what all is in your application. And then you can go and check, and not obviously do this manually, but you can check the CVEs, the NVEs to identify for which components are there known vulnerabilities out there. And so if you can determine, and again, this is we'll talk about a couple options for things to do this. There's an excellent OWASP tool called Dependency Check that will run this. It was originally developed for Java, now supports a couple of the other package managers as well. Really fantastic tool. A lot of really great effort has gone into this, and it's freely available. And what it does is it pulls data down from the NVD, parses that into its own format, and then does an analysis of your application to determine what components you're using, and then matches those with components that have known vulnerabilities out in the National Vulnerability Database. And so it's a really, really fantastic tool, and especially because it's freely available. And so that's it's certainly at least a starting point that you can use with your applications to make a determination. What's all the stuff? What's my bill of materials for what I have in here? And for that bill of materials, are there, what are the potential known vulnerabilities that exist there? The next question that you need to determine is, for this particular vulnerability, what's the impact on what's the impact on my application of including this component? Like I said, with some of the struts vulnerabilities, just having that jar included in your application cause that application to expose certain vulnerabilities. That's really, really bad. Really, really scary vulnerability. In other cases, it's a question of, am I using the parts of this component that actually have these issues? And we did some analysis like that a while back. We use a cut-down version of the ES API for some of the crypto stuff that they were doing. There was a vulnerability identified, potential, what was it? It was like a padding oracle or something like that. Some kind of sort of information disclosure or information leakage vulnerability, which, as Josh was talking about, crypto is not the type of thing you want to see in your crypto. We went and made a determination and looked at, hey, we're using the vulnerable function, but there's no way for this information that is potentially leaked from this process to actually make it back to the user, right? So we were able to go through and make a determination. Oh, okay. Here's the vulnerability. We're using the vulnerable function. The vulnerable function only matters if this information ever makes it out through the browser to the into the response stream. That's not possible here. Therefore, we don't need to make a priority to upgrade this particular part of the application at the current time. But we had to go through that process. Obviously, it's something we took very seriously, but we had to go through that process to make a determination. What's the actual impact? Because going out and replacing libraries is something that's either really, really easy if there's a drop-in replacement, if you're using a recent version of the library and it's well maintained, or you end up in some sort of dependency nightmare where you say, oh, well, this version of Spring has a problem, I need to upgrade that. Oh, but if I upgrade Spring, I also need to upgrade Hibernate. If I upgrade Hibernate, I've also got to upgrade all these supporting libraries. And then you get in a situation where it's like, oh, we've got to tear out a decent chunk of the code that our application is running and upgrade and hope that no API changes have been made, that there's no breaking changes in the APIs, that there's no other bugs that are going to cause regressions and so on and so forth. And so, this is one of those things when we talk about technical debt. If you keep up to speed with it over time, it's something that in a lot of cases goes easier, can be addressed on an ongoing basis. Without too much trouble, but it's also something that if you let go for a long time, you end up in a situation where, as I said, oh, we need to move this, but if we move that, we also need to move that. we don't have a replacement library for this, so we actually have to upgrade to the next major version and made API changes, and now all of a sudden we've got a whole software maintenance project going on to address like one component that has a problem that you potentially have a problem with. So that's an important part of the risk decisions that you make about addressing these types of vulnerabilities. Another interesting thing that I've seen, and I don't know if you all have experiences kind of depending on how your organization develops and delivers software, because we deliver a software platform, we're starting to get a lot more questions from the large financials saying, well, we need a list of all the open source components that you have in your application. All right? And some of them just take it and file it in a contract somewhere, and that's fine. Other folks take it, actually look at it, which is tremendously inconvenient, because they'll come back and say, oh, well, you got these components that potentially have known vulnerabilities in them, and we've got to go through and explain, well, we've done this analysis, here's why this is or isn't a problem, here's the roadmap for when these particular components get upgraded, and so on and so forth. So that's been an interesting thing that I've seen in the marketplace, just being a vendor of software, is we're getting a lot more questions now about about the open source included, and we're starting to get a lot more feedback asking questions or with opinions on what needs to be upgraded, and questions about like what roadmap-wise, when are these things going to be addressed. So again, the example scenario, the risk you have here is that these components run with the same level of permissions as your application, run in the same process base as your application. So we see here a couple of vulnerable components from 2011, downloaded 22 million times in 2011. And that's an authentication bypass for Apache, as well as a Spring remote code execution. All right? And every application using either of these libraries is vulnerable to attacks. As both of these components are deployed in the applications, they're directly accessible to the application users. Right? So those are kind of those nightmare scenarios where just by including this in your application, with the way that application exposes those capabilities, these are problems that you have to address or vulnerabilities that your application will expose. And as we see, downloaded 22 million times in that 1 year, it's not like these were like rare or obscure components that somebody was using. So how do you prevent using components with known vulnerabilities? Most of the open source components that I've followed make security patches for the newer versions, but have some sort of an end of life, right? And unfortunately, this is a situation where for these open source components, obviously they have user communities, they have stakeholders, but at the end of the day, there's not, I haven't ever paid the Apache Foundation something. So while I appreciate them very much for all the work that they do, and I would like for them to continue patching the code of theirs that I use, other than writing like snarky blog posts, I really don't have a lot of recourse against the Apache people for keeping the commons libraries maintained and things of that nature. That's not always the case if you've got commercial support from different vendors, and there's all sorts of kind of joint open source models and things like that. But that's a thing to understand when you look at your policy for including open source into your applications, is to look at, are there situations where we want commercial support? Maybe that gives us access to patches over a longer period of time, or some sort of service level agreement for fixes. Or just understanding like, what are our policies for including stuff? What are our policies for keeping things, keeping these things as up to date as possible? As I said, also, so really what you need to have, and this is something that until recently a lot of organizations simply didn't have in place, is a process in place to identify what are the components that you're using, what are the versions, and what are the dependencies. And there's typically ways, with Maven and whatnot, where you can run with different plugins that will dump out. Here's everything you use. Here's everything that those things draw in. Here's the versions that are used. So that's good. It's easy these days, assuming you're using the tools. It's easy to get a bill of materials for what's included in a given build. Then you need to monitor these components based on info in public databases. Some of the commercial vendors have like secret magic private databases of other stuff that they found. Thanks. But you've got to monitor, well, here's the components I'm using, here's the components that have known databases. And then based on that, what are your policies for how these components get used and when you upgrade them? And in certain situations, and we've had to do this before as well, when we get in situations where certain components are far enough out of life, or where it's too expensive to fix them on a certain time frame, you may find yourself in situations where you've got to go in and patch components on your own to implement fixes or to put wrappers around components to address vulnerable behaviors that they may be demonstrating. But the most important thing here is to have a process in place. Again, so you have the knowledge, so you understand what's the software that's getting included in each build that I've got. All right, so you can say, here's what's in, here's the version of all that stuff. Then using a tool like dependency check or other, again, there's other commercial tools out there as well. How do I run that list of components that I have against the list of known vulnerable components so that I can identify where I'm including components that have risk associated with them? And then having a process or a policy to say, here is how we know what we're going to upgrade and when. And again, if you find yourself in a really bad situation, you may have to go in and take over as a maintainer of that package, at least until you can get yourself into a better situation. And again, if faced with the, well, do I ship my application with this known vulnerable component that has to be exposed, or do I upgrade those components, which is going to take a huge amount of effort to get things fixed and go through regression? Again, you can get yourself in situations that where you've got to make really tough decisions. So again, just to recap, this happens when applications use components with known vulnerabilities. It can undermine all the great work that you've done writing very nice, pretty secure code, because this is also code running in your process space that's going to run with your level permissions. The way to address this is to identify the components and the versions that you're using and have a process in place to check those against known vulnerable versions. When you find that you're using a known vulnerable version, do a risk analysis to determine what the actual impact in your application is, and then make a remediation decision based on that. So, as I said, the dependency check, it says here for Java libraries, that actually wraps a couple of other open source tools, so it gives you one tool that pipelines all these results into one place, and so that's really, that's again, a kind of a cool thing that they've done with the dependency check. A couple of OWASP resources, and there's also some good external resources. And this is one area where I think the federal government has, in certain ways, led the charge. I think there's a lot of things I think you can say about the federal government and application security where they are not leaders. But this is one area looking at the software supply chain and the implications of bringing all of this code in, where they have led the charge. And there's a lot of good work that's been done by folks in the private sector, working with the public sector, looking at this challenge of the software supply chain and a specific issue with that, which is what do we do with the vulnerable code that we identify that comes into our applications from the software supply chain, not from stuff that we've written. Any questions about applications using known vulnerable components? Perfect. Well, now we'll have Josh up here to talk about number 10. Number 10, the unvalidated redirects and forwards.
All right, guys. So here's the deal. The invite apparently said that we go until 4 o'clock, which would have been awesome if we started at 8 o'clock. We've got probably about an hour's worth of content left, or we could have skipped one, but I don't think you would have been very happy with us. We've got probably about an hour's worth of content left. This one is like 10 slides. After that, there's probably like 10, 15-ish slides left talking about the other stuff, and then we're done. So reality is we'll be done probably before 4:30, 4:45, something like that. If you want to stay, stay. If you have to leave, you want to beat traffic, whatever, we won't hold that against you, right? So with that said, let's talk about the last of our OWASP top 10. Unvalidated redirects and forwards. This, other than the cross-site request forgery, is probably my other favorite one. And this is something that you will find everywhere. Once you're aware of it, when you're surfing the web, you will see these all over the place. So what this is applications frequently redirect users to other pages, or they use some internal forwards in a similar manner. Sometimes the target page is specified in an unvalidated parameter, which allows the attacker to choose the destination page. So you'll see this in things like language redirects, You'll see it sometimes where applications have like a redirect to some other thing based on some value you put in there. It's all over the place. But the attacker links to an unvalidated redirect. And by doing that, they trick the victims into clicking. The victims are more likely to click it because the link is to a valid site. It's to a domain that they trust. Oftentimes it has an HTTPS, a SSL certificate associated with it. So the attacker is explicitly targeting these unsafe forwards to trick the victim and in some cases to bypass security checks. The impact here is moderate. In some cases, these redirects may attempt to install malware, they may attempt to trick the victim into disclosing passwords or other sensitive information. They could allow access control bypass. So we want to consider the business value of retaining our users' trust. And I think it was Dan had a good example earlier where you kind of talked about the importance of trust. Right? Our companies are built on trust with our users, and any of these kind of things, like the cross-site scripting he talked about, like this, they violate that trust contract. And customers are a lot less likely to use us, to use our services, to consider us as a partner in the future if that's the case. So, how do I figure out if I'm vulnerable? The best way is to first review the code for all users of redirects and forwards. For each use, we want to identify if the target URL is included in any parameter values. And if so, we want to verify that the parameters are validated, contain only an allowed destination or element of a destination. So in some cases, you'll see a redirect to a specific page. In some cases, it'll allow a full URL. In some cases, it might be a number or some sort of like a GUID for the redirect. But we're looking for that parameter. We can also spider the site and look if there's any redirect links that are generated. So these are usually response codes in the 300 range, 300 and 307, typically a 302, which is a temporary redirect. 301 would be a permanent redirect, something like that. And we want to look at the parameters that were supplied before we got that redirect and see if there's a target URL or some piece of a URL in there. And if so, let's change that. Let's observe if by changing it, it's going to take us to some other site, some other page. If we don't have access to the code, we want to look at the parameters and we want to see if they're part of a redirected forward URL destination and test the ones that do. So we're looking at the parameters, we're looking for things like .html, .php, .asp, whatever. We want to look for those values, .coms, .nets, things like that. So here's an example. In this case, we have an application and it has a page called redirect JSP. If you see redirect JSP, that should like light bulb right there, right? Any page that's redirect whatever, you should be thinking, all right, unvalidated redirects and forwards. That's what you're testing for. And this page takes a single parameter named URL. Again, if you see a parameter named URL, like ding, 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 light bulbs go off. The attacker crafts a malicious URL that redirects users to a malicious site that performs phishing and installs malware. So in this case, you can see along the bottom, we have www.example.com. This is a site that the user knows that they trust. Redirect JSP is a page that exists on the site that one of their developers wrote. The only thing that the attacker had to change is the URL parameter. And they changed it from whatever that internal redirect was supposed to go to evil.com. And the end result in this scenario is that they will be redirected over to evil.com from the site, and that malware would then be installed. In our second scenario, the application uses these forwards to route requests between different parts of the site. And to facilitate this, some pages use a parameter to indicate where the user should be sent if the transaction is successful. So in this case, our attacker is going to craft a URL that passes that access control check and then forwards the attacker to an administrative function that they not normally have access to. So in this case, we're actually using this exploit or this vulnerability in order to bypass access controls. So here we have example.com or in JSP, and we have this forward parameter. So we're validating this URL, which is supposed to be a safe URL, but then it's passing us to admin.jsp, which is an administrative page, and it thinks that we have access to that when we really don't. So how do we prevent this? Safe use of redirects and forwards can be done in a number of ways. First, don't do it, right? If you don't have to do a redirect or a forward in your application, that's the best plan. Don't do it. If you have to, don't involve user parameters in calculating the destination. So if a user can provide a parameter, if it can be passed in through the post on the page or something like that, that's where we're going to run into trouble. So if we can avoid that, which is usually the case, we absolutely should. Third, if the destination parameters can't be avoided, we have to do something. Now we want to check and make sure that the supplied value is valid, which probably means checking the domain, checking the page, checking the path, things like that. And authorized for the user, meaning that user should have access to that page that we're sending them to. Now, it's also recommended that any destination parameter should be a mapping value rather than the actual URL or portion of URL. And what we mean by that is that the URL value in something like this, the forward value, is not admin.jsp. It's forward equals 1 or 2 or some random value. By doing that, we're able to map inside of the application that that value goes here, right? And that value goes there. And if it's not one of those two expected values, we don't do anything, right? So we now, as the developers, are controlling the application. We're controlling the redirects so that it only goes to the places that we have predetermined. Applications can use a SAPI to override the send redirect method to make sure all redirect destinations are safe. I talked about a SAPI earlier. I would not necessarily use this for my application, but you can look at the code and use that as an example for writing your own. Avoiding these flaws is really, really important because they are a favorite target of phishers. Because it uses a URL, it uses the SSL certificate, it uses everything about that URL, so you're gaining the user's trust. And for years, I had one of these examples on my website that I would show our developers, where it basically said, hey, click this link, it's an ni.com link. And nobody had any issues with clicking it because they trusted us, right? But that would just redirect them to a page that looked like an NI login page, and it asked them for a username and password, and they would enter that username and password, and then they'd collect their credentials, right? And this gets even more interesting when you start sending people Bitly links and things like that, right? Because nobody checks a Bitly link. Bitly is 100% trusted, right? You get a Bitly. I gave you a Bitly link earlier today. You're all going to click on that. I know you are, right? So these kind of things are really good ways for attackers, for people phishing, to try and get you to go to a location that you didn't even plan on going to. The recap here, this happens when an application redirects a user to another page using an unvalidated parameter. We utilize a familiar URL to trick the user, bypass security checks. We could install malware, we could trick the user into disclosing passwords or other sensitive information. To find it, we look for unvalidated parameters in our redirect code, and to prevent it, we just need to validate our redirect parameters or just not do redirects at all. There's a good OWASP article on open redirects, and then there's a Google blog article on the danger of open redirects. Those are both good reading. So with that, we have now gone through the entire top 10 OWASP application security risks of 2013. Hopefully you guys learned something there, right? Hopefully there's some information there that you can take away immediately and start making an impact at your organization. Now, we have a few other prominent issues that we feel are worthwhile. And Dan mentioned one of those earlier today around buffer overflow stuff. These are things that are not in the top 10, but they're things that we felt are worthwhile covering because they're common enough issues, depending on the language that you write in, or damaging enough issues that they are worth talking about here. So I'll hand it over to Dan to talk about this.
We'll move through these pretty quickly because we've actually covered a lot of these before, or some of this stuff before, and some of it, like buffer overflows. We could spend an entire day talking about buffer overflows, and I'm too sloppy and lazy to be allowed to write C or C++ code, so I'm also probably not the best person to talk about that. But I want to talk a little bit about buffer overflows just to understand, so that you all can understand what type of applications have the problem, where it exists, and some background. Talk about denial of service, and then talk about information leakage and error handling. And so buffer overflows occur when you have an input that is larger than an application expects, and it's getting placed into a fixed size buffer. And this is almost exclusive or very applicable largely in applications written in C and C++, where you're managing your own memory yourself, whereas like Java.NET, all those have garbage collectors, memory management, and all of this. And so the problem occurs when an input overruns the allocated space, overrides memory that it shouldn't have access to. And so just to look here, if we've got a buffer that we've allocated in C, however many characters that is, at 6 or something like that, you're hoping that when you pull in data, that you get fewer than 6 characters. But using certain functions like getS in C, don't put a limit on the bounds of what you're going to bring in. It's going to pull in data until it's done pulling in data. And so you can run into situations where you end up with something that overruns the buffer and starts overriding other memory that's supposed to be allocated for something else. And so here's an example where we've got in this case we've got a char name with 10. So in theory in C that should be 9 characters and a null character at the end to end up the string. If you call getS, you can pull in as much data as comes in from that input. So, like the challenge here is if you start overrunning or allowing attackers to rampage around in memory, that payload can potentially overwrite things like the instruction pointer that's telling the processor where to jump to next to execute code. And so buffer overflows often result in malicious code execution. Again, and that's why C and C++ are such dangerous applications such dangerous language to use for sensitive software, as we've seen from all the giant problems that are still being released from code that runs natively on Windows, even with a lot of mitigations that have been put in place. Even less sophisticated payloads, if you let somebody come in and mix up the memory in your memory, that can lead to crashes and denial of service attacks. The good news is that most web development environments don't have a lot to fear from buffer overflows. Java, Perl, C#, VB.NET, VBScript, Python, all have their own bounds checking at the language level, and there are. It's not impossible just when you get the bowels of language, or if they're bringing components written in native code. But those environments provide far better protection than C and C++. And there's not a lot of web applications written in C and C++. The good news is that because this is an identified problem, there are a lot of libraries available to do string and array handling. Something that we've also done in the past in Microsoft environments that we're using COM objects that call into native code. Where we're worried about that is we can wrap those COM components in something that does that implements input validation, cleaning, and balance checking before an input gets passed over to into native or untrusted code. For denial of service situations, you want to watch out for scenarios where an attacker gets the ability to use a lot of your resources with a minimum commitment of theirs. We've seen problems with this in logging routines where you have to make relatively expensive calls out to LDAP servers or things like that. We talked about injection flaws. If you're doing processing of XML documents using the document object model, where you have to pull the entire document into memory. You can run into trouble there if you're not bounding how much input someone can add. We also have seen challenges from an operational standpoint with things like logging routines. We once did testing for an application where anytime the application saw a 500 or 404 error, it would email the administrator. It was an in-house, pre-production application. We ran one of our web scanners against it. Those tend to be pretty noisy with the nasty traffic and weird things being posted and things like that. And we knocked out their email server because we sent 10,000 emails for the 10,000 500 and 404 messages that we caused for them. And so this is something where it's good to pay attention around things like XML processing, around things like regular expressions, where, again, an attacker has the ability to, with a few bytes of their data, use up a whole bunch of bytes of memory in your, in your application. And finally, looking at information leakage and improper error handling. This is something we've talked about because it occurs when an application is provides more data back to the user, back to the attacker than they should. We've talked a lot about failing to trap error conditions where you leak things like stack traces, file paths, versions of software that you're running, and things of that nature. But they can also be the result of verbose application messages. And the canonical example of this, if you go and try to log into a system with a username and password, and your username is wrong, if you get a message back that says that's an invalid username and we don't have that user in the system, well, then we know, okay, well, I can keep trying until I get a valid username, and then I can just start working on the password. Similarly, if you try to log in with a username and your password is invalid, and it says invalid password, well, now I know I've got a valid username, and I can go, as Josh talked a little bit about brute force attacks, I can just go try a whole bunch of passwords to see what works. A better approach here is to say things. If you get a failed login, to say invalid username or password. Because given this information, again, attackers are going to learn about the internals of the system, and they can use this to wage attacks directly, or social engineering, to call into a service desk or something like that with additional information. We've talked about unhandled exceptions being sent back to the browser, exception messages, stack traces, file name, and path information. But again, invalid username, invalid password. Where we also see this, a lot of people have gotten really good at the login routine and not returning a verbose error message for the login routine. But where they're bad at it are situations where you go to do a password reset. And they say, well, give me your username, and it'll say, oh, sorry, we don't have a username in our database, or we have that username and we sent a password out. So again, the example that everyone thinks of that a lot of people have corrected was a verbose error message for a failed login routine. Another place we see that is are other scenarios where you're touching the system and getting a confirmation that an email, a particular email address might be correct. Testing applications, we've talked about passing in SQL control characters to test for SQL injection. A handy trick that we also like to use, if you think of the way that HTTP requests get constructed, if you have something in like the get field that says field equals and it's blank, typically the server side will see an empty string. If you get rid of that field equals, typically the server side will get a null. And so you can see different behaviors for applications if they get a null that they're not expecting versus a blank string or an empty string. Same thing, if an application is expecting numbers, set strings, set special characters, and see what comes back. So how do you address these? We've talked a lot about not configuring your application servers to not show verbose error messages. You got to be careful about your error conditions, and again, from a business logic standpoint, be careful about the information you provide back to back to your users. And to be a little more specific, again, there's certain logging error conditions that are important for certain security operation folks. Debug issues, failed login for intrusion detection, and things like that. You want to be careful when you're crafting your login routines of what you allow users to send in or how you handle. As I talked about, if every 404 error sends an email to the system administrator, it's pretty easy to allow for a user to cause 404 errors. And one of the things that we've talked about a little bit is looking at logging error conditions. If you need to have an interaction with the user where you want to allow them the option to help you debug the problem, a way to do that is to log the error message to a database and give that error some sort of a unique ID. and to present that error's unique ID to the user, right? So I don't know that 10293948, whatever that is, I don't know that that means like JDBC error because I saw an apostrophe that I didn't understand, right? But if I need that user to be able to call in and say, well, hey, I'm trying to log into the system and I'm not having any luck, or I tried to transfer money and I'm not having any luck, this is a way for me to create a connection between the customer service representative and the the user of the application that's having a problem. That said, so this allows for that type of communication, but anybody who communicates with users, especially about the state of systems and logging and things like that, needs to be trained in where social engineering attacks. People calling in and saying, well, I've got this error, I've got this other information, can you just turn my account back on and transfer the money for me? Again, in a situation where you do need to have some sort of a connection. Again, kind of your best scenario would be just don't log verbose messages, say an error occurred, nobody needs to know anything more about that. In a scenario where you need to give the user the ability to interact with your customer service personnel, this is a pattern that will allow you to do that, but the human aspect of that is to make sure that you have training for anybody who's going to be interacting with users, because those users may potentially be malicious, and that is a very likely attack vector for people trying to do nasty things too. So with that, we have come to the end. We'll open up for if anybody has any questions for Josh or I for anything that we've talked about. Really appreciate you guys, you all coming out here today. I enjoy talking about this. I assume Josh does. We always link up a couple months before last con and confirm like, hey, we're doing this again. Yeah, we are great. It's fun for me to do. I love to talk about this stuff. Hopefully this has been valuable for you all. Hopefully everybody has the link to the slides. What's that? That's such a great idea. I never think of that. Not terribly. Right. Here we go. There we go. Yeah, that is it again. So hopefully, again, pull this stuff down. Feel free to share this with coworkers. We've got a question. They should be clickable, yeah. You have to hold like control or something to click a link if it's in the, I think so. That particular link is not clickable, but if you didn't have the slides, then you wouldn't, or if you wouldn't need to click that link because you would already have the slides. So the other one should be clickable, I think. Yes.
Go back to the unvalidated redirects. They validate redirects, can someone still use HTTP to bypass that, depending on what's ever being used, whether or not it accepts the second parameter versus first?
I was doing email and Josh was talking about that. I don't know if Josh, you were going to talk about the. Could you repeat your question? Sorry, it was about.
So the validated redirects are validated. They validated the assumption of whatever. Can someone use HTTP parameter pollution, second parameter to take advantage of service that only validate first and second parameters? So the validation's there, but can I use the exact same parameter with different?
Right. Was that a token with a nonce?
No. So we're talking about the unvalidated redirects and forwards, where basically, if you don't validate the parameter, then they could send you off to evil.com or something like that.
Right.
To be honest, I'm not sure about your specific question and where that would fit in with the unvalidated redirects and forwards.
I'll say more by that.
Yeah, typically it's based off of that specific parameter, and that parameter is what is being used by the code in order to redirect. And there's usually code within the page that says, hey, if this is where I'm redirecting to, then basically send a location tag to the browser, which then tells the browser to go someplace else. Or if the page hasn't loaded yet, it's a header tag that says go someplace else. Sometimes it's JavaScript within the page content, whatever. But typically it's based entirely on that parameter, which effectively means if you can change that parameter, then you're changing either that header or the JavaScript or whatever to send it someplace else. Does that answer your question?
Excellent. Well, thank you all very much. And again, I think we're easy to find via email and Twitter and whatnot. So if anything, let us know. Thanks.
is, that's just like an inward.
So then I'll confirm again.
Yeah, absolutely. Thanks for coming. Yeah. It's definitely not bad. But, awesome. That's good to hear. Typically at this point, I'll pull up the 16,000 hours to become an expert, and I would say that you are easily more prepared but security in general is a very big space. Application security itself can be a pretty and so is it always pretty involved that's probably true. Site capability of all sorts of platforms. Those days when they can like upgrade, spend this amount of time, I think it's you learn that. Yeah, I think in there, not probably. Oh, thank you. Machine learning lab. Yeah. I love the application. These guys do you do a lot of I don't. So I limited stuff I do is
was in training.
in application security. Who's the person who's going to be for the same thing? I usually form up. I think they're probably what I do. And I feel like we're but that's what yeah, so it's basically software that does automation stuff around. So yeah, it's basically pretty open source, very knowledgeable. It's in there. I've got a few different. But I've been working on it since 2013. I've got a couple of developers, a couple of yeah. Yeah.
Where is everyone?
I don't know. They're all off taking care of business, I guess. It won't take long. There's only a couple of things to stuff in. I got to figure out how to
We got
turn
like,
this.
what,
I have to figure out.
400 that there's like 7 of us normally do,
Yep.
and there's only literally 2 of us standing here.
Hold on, hold on. How do I turn this damn thing off? Does anybody know? Power. That looks like